So I just want to check to see what the issue is here. I think it's because this has got a capital L. Let's see if that makes any difference. That's better. Small things like that can drive you crazy. So I thought maybe the file was named incorrectly, but as you could see, the constructor name didn't match the class name because of a mismatched capitalized L. So just be careful about things like that. It can drive you kind of nutty. All right, fantastic. So that's the first part of our constructor setup, but again, we're only a small part of the way there. So the next thing we want to do within our constructor, again, as I say, this is where we're going to set up our connection to our message bus. We want to set up what's called a connection factory. Now this is a RabbitMQ concept, not dissimilar to a HTTP client factory, similar sort of idea. Allows us to create connections basically to our RabbitMQ instance. So I'm going to create a variable, I'm going to call it factory. I'm going to make it equal to a new connection factory. And we're going to have to bring in a namespace, control period, using RabbitMQ client. So it's a RabbitMQ concept. All right, and then we're going to define what our configuration elements are, what our connection stuff is. So the host name is going to be equal to, we're going to access our configuration instance, and then we're going to specify the name of our configuration element. So control B, and we're going to come down to either one of our files because we've named them the same thing. Now that's a really important point. These have got to be named the same thing. So RabbitMQ host and RabbitMQ host. The values are of course different. So we want to inject in our host value into here. So control B, and we'll paste that in here. That's the first part. Okay. And then we want to specify the port. Now the port value is an integer. Now we have stored our configuration element as a string, not a problem. So let's build up step by step. So we're going to access our configuration and we're going to access the port element. So we come back over here, we'll copy this, bring it back here and paste that in here. Now I'm just going to move to the end of this. It's getting a bit long, so maybe I take a new line, maybe that's what we do. And I'm just going to put a semicolon at the end there. Now this is not going to work because we are expecting an integer, so what we're going to do is we're going to say int.parse, and then we're going to wrap that in a pair of parentheses. And that should stop erroring out. Fantastic. So let's just save that off. Just do a quick build just to make sure we're on the right track, because we say we've got a few steps to go in this class and I want to make sure we're not making errors as we move along. So that's all looking pretty good at the moment. Fantastic. So we've got this factory, connection factory object now that we can actually build connections off of. So this next set of stuff we're going to put into a try catch block. So try, because obviously stuff can go quite wrong here. Catch, we'll catch the exception. We'll call it EX, and then in here, write line, and we'll write out something. We'll use string interpolation, so $, double quotes, put the semicolon at the end, and we'll just say could not connect to the message bus. And we'll put the exception, put a colon there, and put the exception in here so we know kind of what issue we have, and it's more than likely going to be the service isn't available, the RabbitMQ bus isn't available, something of that nature. Alright, so we've got a little bit of setup to do now in our try block. So the first thing we actually want to set up is a connection. So what I'm going to do is I'm going to create a private read-only field called connection. And I'm going to make that equal to a factory. And I'm going to call the create connection method on that. So of course, control period, and we want to generate a private read-only field. We put that up there, and that's added up to the top. So this is our connection now. The next thing we want to do, and again this is RabbitMQ specific, is create something called a channel. So underscore channel, and that's equal to our connection, and we do something called create model. So again, the way RabbitMQ works is kind of, again, it's a bit like Kubernetes, it's multi-layered, there's multiple things we have to set up. We have to set up a connection, we have to set up a channel, and then we have to set up an exchange. So again, just the way it's architected. So again, we'll create another private read-only field for our channel. So generate read-only field, and again, make sure it's being added up here. Next thing we want to do off of our channel is declare an exchange. So we're talking about fan-out exchanges, direct exchanges. This is where we declare our exchange. So exchange declare, and into here, we'll use exchange. We'll give it a name. I'm just going to call it trigger, as we're triggering messages. And then we specify a type. And this is where, make sure you put the colon in, our exchange type. And we specify, you can see the different types here. We specify it's a fan-out exchange. Okay, so we've got a connection. We had to create a channel off of our connection, and now we're now declaring an exchange off of our channel. And at this point, really, we should be pretty much connected to our RabbitMQ instance. But what I'm also going to do, because we might use it at some point on our connection, we're going to subscribe to the connection shutdown event, because we maybe want to do some stuff in there. So we'll subscribe to that event, and I'm just going to call it RabbitMQ _ connection shutdown. Now this doesn't exist yet, so we'll just come outside of our constructor, and down here we will just declare that private void, copy the name, we'll get the object sender. And again, if you've not worked a lot with events before, this is basically an event will be triggered when the connection shuts down, and we can put anything in this method here, basically, when that event triggers. I'm not actually going to put too much in it. In fact, I'm going to put nothing in it for the moment, but we may come back to it at some point. Well, I'll tell you what we will do. We will put in a console write line just to say that our connection has been shut down, just so we're aware that that may have happened, and it helps us debug, doesn't it? So write line, and we'll just say RabbitMQ connection shutdown. Okay, so if you don't want to put this in, you don't really have to. I'm just putting it in just to be a bit more kind of, yeah, it gives us a bit more detail if something does shut down. But at this point, we should be connected to our RabbitMQ instance. So again, I'm going to put console write line, and we'll say connected to message bus. And we'll save that off. Fantastic. Okay, so that's our constructor done. That's basically our connection done. So the next thing we want to move on to, which we will do in a second, is basically create our publish new platform message. So we'll do that next. All right, so on to publishing our platform, actually implementing our main method here. So let's get started. So we'll take out the exception that we've got there. The first thing I want to do is create a message object. And that message object is basically going to be a serialized version of our platform publish DTO. So we're going to use JSON serializer. And I need to bring in a namespace for that. So again, use system text JSON. And we're going to call the serialize method. And what are we going to serialize? We're going to serialize our platform publish DTO, because we're going to send it over the wire. And ultimately, we're going to convert it to a byte array. All right, so got that as a string now, basically a serialized string. And then all this method is going to do is going to check to see if our connection is open. And if it's open, then we're going to actually send it. And I'm going to put the send functionality into a separate method. So we'll leave that blank for the moment. Well, I'll tell you what, we'll put our console write line in just to help us with debugging. So console write line, and we will say RabbitMQ connection open sending message. ... Fantastic. And if the RabbitMQ connection is not open, then we'll do a console write line saying RabbitMQ connection is closed, not sending. Now we could start getting into retries and all that kind of stuff. I'm not going to implement that today. It's just going to take too long, but we'll just write out a message for now to say that we were unable to do that. So we will come back here and we'll put a bit of a to-do in. You still have to actually send the message. Now we could put it in here, but I just feel it's a bit cleaner to pull it into a separate method. So I'm going to make it a private method. Void, I'm going to call it send message. And we're just going to expect a string of message type. Now the other reason I'm doing it this way is that we are exposing this publish new platform as a method on our interface. It's conceivable we're going to have a number of different methods, so publish platform, publish something else, whatever it happens to be. So this send message method, I want it to be generic, reusable by any other methods, and we may just have, you know, a range of other methods that we expose to do other specific things. So that's the other reason I'm kind of pulling it out into its own method. Send message is just totally generic. So I want to now create the body of our message that we're going to send, and it's going to be a byte array effectively. So var body equals encoding, I'll bring in the namespace, system text, and then we'll say UTF-8, get bytes, and then we'll pass in our message. Now while I remember, I'm going to come back up here, and I'm actually going to call send message from in here, and we're going to pass over our message that we constructed up here, our serialized message, just in case I forget, which I probably will. So that's this method finished, and now we're just going to complete our send message method. Then all we actually have to do now is on our channel, we just need to publish our message. So we'll call the basic publish method. Here we are. And we have to specify the exchange, which we called, when we declared it up here, what did we call it? Trigger. So this is possibly something you'd want to pull into config as well. You don't really like to have magical strings in our code, but anyway, we'll brush over that for the moment. Get rid of this. The next thing we need to specify, which we are going to ignore, is a routing key. Now you'll remember fan out exchanges ignore the routing key anyway, so it's just going to be nothing. Okay, these tooltips can be useful, but they can also be quite annoying. I find sometimes the tooltips appear when you don't want them, and they don't appear when you do need them. Next thing is basic properties, and that's just going to be null. And we keep getting that, quite annoying. Our body is going to be our body that we've declared here. And that is basically it. Okay, so basic publish, what exchange are we publishing it on? Routing keys are relevant anyway. Basic properties we just set to null, and the body is what we've encoded here. And then really, at that point, we can say console write line. And we'll use string interpolation, and we'll say we have sent, and we'll put in our message here. Fantastic. So that is pretty much it. The only other thing I want to put in is a dispose method. So when our class dies, we clean up anything that's left behind. So public void dispose. I'm just going to do a console write line because I like to understand when these things are happening, and we will say message bus disposed. And we'll just check to see if the channel is open. And if it is, then we will just close the channel off. And then we'll close our connection off as well. Fantastic. So I think that is us done. So let's just do a quick .NET build. And we're all good. Fantastic. Now, before we move on to actually using this now, one last thing I want to do, because it's the thing I'm tending to forget at the moment, is we want to come over to our startup class and we want to register for a dependency injection, our iMessage bus interface, and the concrete class. So back down in startup, let's get rid of that. Come back up to configure services and let me just get rid of that so we get a bit more room. And after our HTTP client, let's add a registration for asynchronous client. So this time we're going to add a singleton. And the idea of this is that we're going to use the same connection throughout the rest of our application, so we add a singleton lifetime basically, is why we're doing that. And we'll add an iMessage bus client of type message bus client. All right, and let's just bring in the namespace. Oh, my butterfingers there, so control period, and yeah, using platform service async data services, and that should resolve them both. In fact, it does. Fantastic. So that should be our asynchronous data client setup, which is rather exciting. So now what we want to do is we want to use it from within our controller. So when we create a platform, not only are we going to still send a synchronous message to a platform service, which we're still going to do, we're now going to drop a message onto our message bus. So we're getting towards asynchronous messaging between our services. So we'll do that in the next section. All right, so we're almost at the point, well, we are actually at the point where we can use our message bus client now. So we're going to do a control B, make sure I'm in the right place, and we're going to come back to our controller. So let's do a quick review of our platform's controller. So control B, again, let's come up to the top. So we have our constructor and we're passing in a repository, fine, our mapper, fine, and also our synchronous data client or HTTP data client. And down in our post action result where we're creating a platform, we're doing all our usual create platform stuff, but you'll remember down here, we then actually attempt to send a message to our command service using HTTP. All right, so we're now going to put in another component here where we're going to send a message asynchronously. So back up to our constructor, we're going to add to the things that we are passing in via our constructor using dependency injection. So this time we're going to pass in an iMessage bus client, and that's going to be equal to, it's going to be called message bus client. And we need to put a comma there. And we should bring in the namespace. So yep, using async data services. Fantastic. And then down here, we're going to create a private read-only instance of that. So message bus client equals message bus client. You've seen this 1,000 times before now, and we'll generate a private read-only field. Super. And that's why, of course, we had to, again, I'm just labouring the point, we had to make sure we registered this here. That's something I usually always forget, but we've done it this time. So back down into our create platform method, what I might do, although it's obvious, although you can read it in the code, I might just to do a little bit of documentation and say send sync message. And then under here, we're going to send our async message. All right, so again, we'll put it in a try catch block because it's something that could conceivably go wrong, and we'll deal with our catch first. Oh. So we'll catch an exception, EX. I'll do a console whiteline. I might just copy this here. Saves me typing. And we will just say could not send asynchronously. There we go. So the first thing I want to do in here is create a published DTO. So we created our published DTO. We want to map into, well, we want to create one basically. So we'll call it platform published DTO. And that's equal to mapper map What do we want to map to? We want to map to a platform publish DTO. And what is our source? Our source is going to be our platform read DTO that we have up here, hence the mapping that we created. So you could create other mappings. You could conceivably create the mapping from, rather than mapping from a platform read DTO, you could map from the model. That's a possibility as well. Up to you how you want to do it. Now you'll remember, if we just do a Control B, over in our, let's have a look at the DTOs, in our platform publish DTO, we had all this stuff here, fantastic, but we also had this property called event. Now that is not, event is not available as part of our platform read DTO. So we need to explicitly add that in. And that's just to help us identify at the other end what type of message event has been sent out. So platform published DTO, we'll find the event property and we will just make that equal to platform published. Now you would probably want to have a kind of, you would want to document the events that this service emits. In fact, within your entire microservices architecture or application, you would want some kind of documented library of the events that can be expect to be sent and received along with the payloads and all that kind of stuff. I'm trying where possible to keep the payloads as standardized as possible. All right. And then finally, moment of truth, we use our message bus client to publish a new platform, and we just send that onto the wire. Fantastic. So we are almost at a point where we are going to test this. So I'm just going to save that off, and in the next section we are going to test this. We'll spin up our, and we'll test it locally. We'll spin up our command service locally. We'll spin up our platform service locally. We should see it connect in when we send, see it connect in, and we should see it send a message once and only once we create platforms using the controller. So we'll do that next and see how we go. All right, so let's run up our platform service. So .NET run. Okay, so let's just take a quick look at the output. Shouldn't be anything different than what we've already seen before. So where is it? Yep, so it's using the in-memory database, which is correct. Our command service endpoint is our command service, which isn't running yet, and we've seeded data. Now, a point to really note here is that we're going to run up our command service now locally for the asynchronous stuff we've just done. That, well, it doesn't need to be there anyway, because again, all it needs to be there is the message bus. So the reason we're running it up is so that the synchronous part of our messaging will still work. And we'll actually shut down our command service as well to see what happens when that is not there and how the synchronous stuff behaves. So we've got our platforms service up and running. Let's come back to our command service. Over here we are. And let's do a .NET run. Fantastic. So again, it's running on localhost 6000, which is good. And then we'll bring up Insomnia. And we will come back to our local development environment, back to our platform service, and we're going to create a platform. Now I might just move this, because we're slightly running out of screen real estate, but let me just do it in Insomnia and we'll see what we get. So let's send this over. So that's cool, we got our 201 created, fantastic. Let's move back over here. So this is our command service, and you can see we still got the inbound post, which is all that we're doing, fantastic. But more interestingly, if we come to our platforms controller, you can see that we connected to our message bus, which is good. Our sync post was okay, obviously, because we just saw it was received by our other service. And then you can see that the RabbitMQ connection was open and we were sending the message. And then finally, we sent the message, we dropped onto the message bus. So that's all looking really rather good. And you can see here, boom, in our RabbitMQ message bus, yes, indeed, there was a message placed on to the bus. Now, off screen, I've got Insomnia. What I'm going to do is I'm just going to rapidly fire some, you can hear me clicking, I'm going to rapidly fire some events in here. And we'll wait for this to catch up and you'll see how that should manifest. So I've just basically blasted a load of commands onto the message bus. So maybe we need to get this to update a bit quicker. Maybe I do a few more, and you'll just see I've only put a couple on, and you'll see how that compares to what we just blasted on. Holding our breath, there we go. So there's a few more. So that's all looking really rather good. So again, we've dropped stuff asynchronously onto our message bus. Our command service is only getting synchronous messages via HTTP. We still have to build in the subscriber. We've not done that yet. But let's come back to our command create service. And you can see here, command service, all the inbound post commands. And I'm going to stop this now. Okay, I'm going to do a Control C. So our endpoint is now down. Synchronous endpoint is now down. Now I'm going to click send, watch what happens. We get spinner, we're waiting. That is because our platform service is attempting to send a command to a synchronous endpoint, and it has to wait for the message to come back to go either successful or unsuccessful. And there's, I'm sure, a default timeout window that we will wait for. Again, just to demonstrate again, it's waiting. Now you can imagine this whole idea of a dependency chain where you have hundreds potentially of services all doing that, how that could stack up and cause massive delays just because that endpoint is not there. What you will also realize though, as we come back to our message bus, once the synchronous messaging component failed, the asynchronous stuff still went ahead and dropped our asynchronous messages onto the message bus, because that's still there and that's still running. So you can start to see the differences between synchronous messaging being problematic if it's not there, and us just dropping async messages onto the message bus. All right, so that is all looking pretty good. So I think what we should move on to next is we can do one of two things. We can either deploy this into our Kubernetes cluster, which I'm probably not going to do. I think what we do next, because this was successful, is we build up the subscriber in our command service so it can actually receive the events from the message bus. So we'll move on to that in the next section. All right, so let's make sure we are over in our command service, and I'm just going to, before I do anything else, make sure everything else is shut down. Let's just shut that down as well. Okay, so back over in our commands service. Now, I'm going to give you a bit of warning here. This is actually by far and away the most complicated part of the whole video. And that is basically allowing us to, number one, subscribe to the message bus, and then two, determine the event on the message bus, and then do something with that event that we've determined. So there's quite a few things that we need to build up here. So we're going to have to add 2 new DTOs to our command service. We're going to have to add the RabbitMQ config to our config file. So we'll do that next, and that's quite straightforward. You've seen that already. We're then going to define what's called the event processor. And the event processor is basically going to determine what type of event did we get. So again, the RabbitMQ pipe is stupid. We're just getting events. So we need to find a way of determining what was this event. Was it a platform published event? Was it a shipping event? You know, there could be a million different events. So the event processor class is really determining what was this event and then doing something with it. And then we're going to write the class that actually connects to the message bus and receives events, because it's dependent on this event processor. So we have to build it up in the order in which they're used. Okay, so there's a lot here. Conceptually seems quite simple, but the implementation, there's a couple of little really gnarly things in here to do with the way dependency injection works, service scopes, service lifetimes, and we're going to be doing some kind of interesting stuff around getting access to our repository. And there's a lot going on here, so you do need to pay attention. All right, so in this section, what we're going to do, just some simple stuff to begin with. We're going to check that we've got the RabbitMQ client library, simple enough, and we're going to create our config, and then we'll move on to the next section. So, commands service, commands CS proj file. Let me just get rid of this for the second. Make sure I'm in here. And yeah, we don't have the RabbitMQ package, so .NET add package. And it's RabbitMQ. Keep saying MQ client. All right, simple enough. And there we go, that's added in, very good. And then, like we did with our platform service, we want to add in configuration elements to both our production and development app settings JSON files. So we'll do a Control B. And what I might do is I might select our app settings development JSON, and I might just come over to our platform service, and I might just copy in those files. So here we are, platform controller, platform service should I say, and I'm going to close all this down. And we'll come to our development JSON, and I'm just going to copy these because it's exactly this, connecting into the same message bus. Okay, so I'll copy these over. All right, and I'll paste those in. And doesn't like that. I need to paste it inside here. Paste it in here. That's better. I'll tidy that up by doing an Alt, Shift, and F to format our file. Save that off. Fantastic. And then we'll select our. We've only got an app settings JSON file here. That's interesting. We don't have a production settings file yet, so let's do that. So in the root of our project, right click, new file, and we'll create an app settings.production JSON file. And we will come back to our platforms class, platform service, get rid of that, go into our production class, and we will just copy this out. Actually, we only need the two elements, so copy that, and back over in here, we need to put in a pair of curly brackets, and this is our config for our platform service. So platform service or command service in production. Okay. All right, so command service, we got our development configuration and we have our production configuration, remembering that it's the RabbitMQ cluster service IP name that we want for production. So that is our sort of basic config setup. Next, we want to move on to doing our DTOs. All right, so we're wanting to create some DTOs now to support receiving platform event messaging down at our command service. So let's just close this down and we are back in our DTOs folder. So the first DTO we want to create is the platform publish DTO. .cs. So again, we're dropping this DTO onto our message bus from our platform service. We want to take it at the command end and use it and add it ultimately to our database. So namespace is command service DTOs, and then it's just a public class called platform published DTO. And what I might do, just to kind of save a bit of time, is come back to our platform service and just copy these properties over into here, as they should be exactly the same. Fantastic. Now ultimately what we're going to do is we're going to get this, receive this, understand that we've got this, and we want to then create a model in our command service database. So if we could take a quick look at our models, it's the platform model that we want to create, obviously. The ID is taken care of by our database, so we don't need to worry about that. The name we are getting here. We're passing over this additional event property, which our platform doesn't care about, and we're going to use that for other purposes. But we have specified that we do require this external ID property. Now, what that is going to ultimately be is it's going to be the ID of the platform in our platform service. We're going to use that as the kind of unique global identifier. So we're going to have to map between platform publish DTO and platform DTO. Now, unlike previous times where, you know, in the case of name, it's just a straight through exact mapping. AutoMapper can do that for us without any additional config. In this instance, we are going to have to tell AutoMapper that we want to map ID to external ID. And so this is where the AutoMapper stuff starts to get a little bit more interesting. So before we do that though, let's just create our other DTO. And there's one more, it's a very small one, call it new file, and we're going to call it generic event DTO.cs. and we'll just create a namespace. Namespace, and that's command service DTOs, and it's just a public class called generic event DTO, and it's just got one property. It's a string, and it's just called event. Now I'm not going to go into the details of why we have this just yet. We'll come on to that a bit later, so just stick a pin in that for the moment. And we don't need to use AutoMapper to map this either. That's just something we use a little bit later. But we do need to come back to creating a profile now, and a profile mapping that's going to map our platform publish DTO and map it to our platform model. So we'll do that in the next section. All right, so let's come down to our profiles folder, and in commands profile, we want to add in a new mapping. So we've seen this before, so create map. What is the source? The source is our platform publish DTO. That's what we're going to get over the wire. And we want to map it to our platform object, which all sounds very reasonable. And we'll just close off with a parenthesis. But as I said in the last section, we want to explicitly tell AutoMapper that we want to map the ID of our platform publish DTO to the external ID of our source, of our target, sorry, of our destination. So let's do that. So the way you do that is don't put a semicolon here. You come on to the next line if you want to make it look a bit neater. You can have it on the same line as well, obviously. And we do for member. And then we specify lambda expression, destination. So this is where we want to map to. So we say the destination, which is ultimately our platform object, dest. And it knows that our destination is a platform object, so we want to select the external ID property. We then select some options. So OPT goes to OPT, and I'm just going to do a Control B to give us a bit more room, so we can see what's going on here. And then we want to specify on this option, map from. And then what are we mapping from? We're mapping from our source, which is our platform publish DTO. And what are we mapping from? We're mapping from ID. Okay, and we'll terminate that with a semicolon. And everything else should map through okay, but that is our explicit rule saying at our destination, which is our platform model, we want the external ID to be mapped from the ID of the source. All right, and we'll save that off. So that's our mapping setup. Now, I'm going to preempt something that I want to do a bit later, and what that is when we come and we receive this platform published object, we have to do a lot of stuff before we get to that, or after we get to that. We want to determine that we want to put this model, this object, into our database. Now we want to make sure that we're not duplicating the same platform in our database. So we're going to do another repository method to say, given an external ID, do we already have that external ID in our list of models? And if so, then we don't add it. So it's very similar to the platform exists method. This one is just slightly different. We're using the external ID this time. So I'm just going to add that to our repository ahead of time, and then we'll use that a bit later in our event processor class. So we'll do that next. All right, so let's just do a Control B and close this stuff down, and we're going to come back to our repository. We're going to use this a bit later, so I'd rather just get this done ahead of time than do it at the point when we need it. So back over in iCommander repo, we already have this platform exists, and that's checking to see whether we actually have a platform with that URI in our database. We're going to create a very, very similar method. Let's call it platform, well, we'll call it external platform exists. And this is just going to be used to check that we're not going to add additional platforms into our database when we already have it there. Okay, and so we'll say int external platform ID. Fantastic, and we'll get an error now on our concrete class because we've not implemented this, and I'll just pluralize that, so external platform exists. That looks okay, fine. And then we'll come over here and we'll just come up to here and do a control period to implement the interface, and that will put it down down here somewhere. Where's it gone? There we are, external platform exists. Now what I might do is find our platform exists method and just copy this because it's going to be very, very similar to that. So in here, we'll paste in return context platforms NA, P goes to P, and this time it's not on the ID, it's on the external ID is equal to the external platform ID. All right, so again, similar concept. We're just going to check to see whether we have that because we do not want to double add more and more platforms if we've already got them, and we're doing that based on the external ID. Fantastic. So just a quick change, and now what we're ready to do is we're going to move on to our event processor class. All right, so on to event processing. So just to give you a quick explanation of what this is, we've got two main bits still to do, and that is the event listener, effectively. We're going to do that later. This one is the event processor. So upon getting an event, which we'll do later, we need to determine what is this event? What is it? Is it a platform published event? Is it something else? So upon determining what the event is, we then want to do something with that. And what we're going to do is we're going to add that platform to our database, assuming we don't already have it in there, hence the last section. So that's ultimately what we're going to do with the event processor. Now, I will call out that we only really have one event that we're interested in our platform. If you had lots more events, then the way I've built this class, you would probably want to decompose it a bit further. But for our purposes, I think it's fine. So back in our command service, let's close everything down. And we're going to create another top level folder called event processing. Now this next bit is actually, there's quite a lot here and there's a few interesting concepts in it, not most especially around dependency injection. It can get a little bit gnarly. Anyway, so we're going to create an interface first because as always we're going to use sort of dependency injection. So new file, and this is called event, capitalize the E, processor.cs. All right, now this is actually going to look very, very simple, but behind the scenes there's a lot going to be going on here. So namespace command service, event processing, and then it's just a public interface called event processor. That's right. And it's going to have one method called process event, which seems benign enough, and it's going to take a string called message. Very, very generic. So ultimately we're going to get this message string from our event listener service, which we've yet to build, and it's just going to be our object or event string. So we're going to have to take that string and understand what the heck is this, deserialize it, find what event it is, and then do something with it. So a very benign looking interface, but there's going to be a lot going on behind the scenes. So let's not mess around anymore, let's create it. So new file, still in event processing, and we'll call it event processor.cs. And let's do the easy stuff first. So namespace, command service, event processing, and it's just a public class called event processor, and it's going to implement my event processor. So as usual, let's implement the interface, implement the placeholder, but we're not going to come on to that just yet. Now the first thing I'm actually going to do is I'm going to step outside this class, and in here I'm just going to create a very simple enum. So enum, and we'll call it event type. And this is just listing out our event type. So we're going to have platform published and undetermined. Okay, and that's the only ones we're dealing with. And the reason I'm creating an enum is I don't really like working with magic strings, so this just gives us a bit more structure around the types of events that we can have, and you'll see how this is going to get used in a second. And now just make sure you create that outside the class. All right, so we're coming on now to our class constructor, and again, coming back to the intention of this class, it's to take a message, determine what it is, and then we're going to add, if it's a platform published event, we're going to add our platform to our database. So immediately you're going to think, well, that's cool. That's just constructor dependency injection. That's just injecting a repository into this class. Unfortunately, in this case, no, that is not the case. We cannot do that. And the reason is for rather torturous dependency injection reasons. So I did kind of brush over it a bit earlier in the course, but when you register your services in Configure Services, they have what's called a service lifetime. So scoped, transient, or singleton. Now, singleton registered services, they exist for the lifetime of the application, basically. Scoped services, they exist kind of for every kind of session, and then the transient ones, it's every request. So they have different lifetimes. So singleton ones last for the entire length of the application. Fine, you may say. When we come on to creating our listening service, that is going to be created as a singleton service ultimately. It's going to be there for the lifetime of our application. And that service is going to call this service. And in order for that to happen, in order for us to inject this event processor service into our listening service, it too has to have a lifetime the same or greater than the service it's being injected to. So this service is going to have to be a singleton service as well. Fine. If we then try and inject in a repository and ultimately further down the food chain a DB context, those services have been registered with a shorter lifetime, and you can't do that. Freaks out, okay? It's not good practice. So in a long and roundabout way, we cannot inject a repository into the constructor here. We're going to have to inject it, well, we're going to have to create it, a reference to it in another way. So that's what we're going to do here. So coming back to this, probably become a bit more understandable when we actually go through it. So class constructor. So instead of injecting a repository, we're going to inject something called an I service scope factory. And we'll call that scope factory. And the use of the, we'll just get rid of the thing at the side there, and the use of the term factory, you might start to have some idea of what this may allow you to do, or maybe you don't. And I don't blame you if you don't. But the good news is we can still inject our IMapper in, so in the usual way. That's fine. And we'll bring in the namespaces for this, and we'll have to capitalize that. So let's bring this in. Microsoft Extensions Dependency Injection and AutoMapper. All right. I may actually just take this back up onto this line. I don't like using multi-lines unless I really have to. So again, we're going to create some private fields. So scope factory equals scope factory, and mapper, or underscore mapper, equals mapper. And then we'll create some read-only fields for these here. Read-only field, and correct that, and bring in a read-only field for that as well. Fantastic. So we'll come on to using the scope factory a little bit later when we actually do have to use a repository, but stick a pin in that for the moment. So the next method I'm going to create in here is in support of our publicly exposed method, which is process event. It's a private method, and basically this is the method that's going to determine what is the event that we got. And ultimately what it's going to use, if we come back to do Control B and we look at our DTO, we look at our platform publish DTO, we are passing through this event attribute here. And we're going to basically look at that and see what that is. And you will remember from, or maybe you don't, from our platform service over in our controller, when we generated our synchronous message, we set that event to this field here, to this string here. So we're basically just going to ultimately look for this string to see and understand whether it's a platform published message. So back over in our command service, let's get rid of that and let's come back to our event processor. So this is a private method, and we'll call it private event type. So it's going to pass back an event type that we defined here. And we're going to call it determine event. Into that, we're passing the string that we get passed through from our, ultimately from our event listener, and we'll call it string notification message. Fantastic. Okay, then I'll do a console write line. Bring in the namespace for system. And we'll just say something along the lines of determining event. Fantastic. So the first thing we want to do is basically deserialize this string into an object. Okay, so I'm going to create a var, call it event type, and we're going to use our JSON serializer, and we're going to bring the namespace in first before we start to use it. So system text JSON, get rid of that, and we're going to deserialize this time. Now what we're going to deserialize to, well, again, to bring this back up, the reason we created this generic event DTO is we're going to deserialize to this because all we really want to pull out from any message anywhere in our microservices platform is this event property here. So when we deserialize it, we want to deserialize to that. Now, in days gone by, if you're using the JSON, the Newtonsoft JSON library, you could use what's called dynamic deserialization, and that means it kind of does it on the hoof. I didn't like that anyway because you kind of end up with a non-typed message, which I don't like. So this is typed, using dynamic as non-typed, and it leads you into all sorts of crazy madness, which is not, I don't think, best practice anyway. So long and short of it, we're going to deserialize to a generic event DTO. And what's our source? Source is our notification message. So this is really just to enable us to get at that event attribute. And we'll just bring in the namespace for this. And I think I've spelt it totally wrong. Gen-er-ic. No T. Let's try that. That's much better. Okay, so we have our generic event here. And then all we want to do is just switch on that. So switch. And we'll access our event type and access the event on it. And I'll just move this up, and then we're just going to do some case statements. Case. And I'm going to come back to our platform service and have a look at what we passed over. I'm just going to copy this. And I'm going to paste that in here. So if our event is that, then of course we can be confident we have a platform published event. And I'm going to do a console write line. And we'll say platform published event detected, and we will simply return back event type of platform published. Fantastic. And that's the only sort of switching we're going to do, so we will just round off with a default, and we'll just write console write line. Whoop. And I'll use this, and I'll actually do that up here as well because I've been using it all throughout the application. So let's keep it consistent, and we'll say could not determine the event type, and we'll just return with that. Oh, actually, we need to return the event type, which will be not platform published. That will get very confusing. Undetermined. There we go. That's great. Fantastic. So again, the whole point of this private method is just to ensure that we can understand what event we got down the wire. And our process event is then literally going to do something. Well, it's going to see what we got back, and it's going to then action it, do something with it. So we'll take a quick pause here because this video's been going on quite long, and we'll come back and we'll finish off our process event and one other method of this class. All right, so let's come back to our process event, and actually just don't forget to save your work just in case something crazy happens. So in process event now, this is kind of our main publicly exposed method. All we want to do is we'll create a variable of event type, and we'll make that equal to determine event, and we'll pass over the message that we get here. So we've kind of, subcontracted the determination of event to this method here. We now have that in our event type, and then simply we just switch on that. So we'll switch on event type, case. So case event type is platform published. Then we want to do something here, and then we'll break. And then we'll just put a default in, and we'll do, we don't need to do a console write line because we already kind of had that from here, so we'll just leave it. We'll just break it. Probably a bit redundant, but we'll leave it like that. So what do? We've got a platform published event. We want to actually add it to our database. That is ultimately what we want to do. Now, I would probably, going forward, move out the kind of classes that we use to action our events. Possibly, I'm not sure I would wrap it into our event processor, but I have for this video, and I feel in this instance it's totally okay. So still within our event processor class, we're going to do one more private method, and I'm going to call it private void add platform. And we're just going to expect in a string, and this is effectively our published platform DTO, but it's still in a string form, so we'll call it platform published message. Okay, now this is where we're going to start using our scope factory to actually get a reference to our repository. So we'll start off with a using statement. Determine or declare a var called scope. Our scope is going to be equal to our scope factory, create scope. All right. So then within here, we're going to create a variable to contain our repository. So we'll just call it repo. And that's going to be equal to our scope, service provider, get required service. And what type of service do we want to get? We want to get an I command repo. Okay, so basically getting a reference to this in this way, as opposed to injecting it through constructor dependency injection. And again, it all comes back to the service lifetime of our repository and this class here. So again, a bit gnarly, but it's definitely useful, and it's going into the more detailed use cases around dependency injection. So the next thing we want to do is not do that. We want to create a variable, and this time we want to essentially deserialize our platform published message into a proper platform published DTO. So var platform published DTO is equal to JSON serializer, deserialize. What do we want to deserialize to? Platform published DTO. And what is the source? Again, this is very similar to the mapping syntax that we use with AutoMapper. We want to deserialize this here. And that's okay, the namespace is already there, so that's cool. So this will then be our platform published DTO. And then finally, we want to try and add this to our database. So I'm going to put this in a try catch block. And so I'll do the catch statement first. And we'll just do a console write line. And we will say, could not add platform to DB. And we will put in our message in here, so EX message. Don't forget the semicolon, which I'm sure you won't at this point. I've been doing quite a lot of coding here. So within our try block, what we want to do is ultimately get a platform model. So multi-stages of converting objects, so var plat equals mapper, not scope factory, mapper. And what we're mapping, we are mapping to a platform. And what are we mapping from? We're mapping from a platform published DTO here, this here, okay. So we'll leave it as is, bring in the namespace for that. And again, semicolon. Great, so we've got our model now. So all we need to do is determine whether we want to add this platform to our database. And that's where this new repository method comes in. So if repo, or if not repo, we'll do external platform exists, and we want to access on our platform object our external ID, and that should have been mapped through. So if it doesn't exist, then we will create it. Otherwise, we will do something else. And in fact, we won't do it. Well, we will. We'll write out a message because we're going down that path, aren't we, of writing console write lines. So we'll do that again. Write line, and we'll just say platform already exists. So we won't bother adding it. Fantastic. And then finally, in here, we will do repo create platform, and we'll pass in our plat object. And then finally, we'll do repo save changes. Otherwise, it will not get added. And I think that is that. That is our event processor class. So, you know, logically, it doesn't sound that complicated, but you saw there was some fairly interesting things going on in there. So let's do a .NET build. That's all looking okay. Don't jump the gun. Now the one thing, again, not to forget this, let's put it in. Control B. Over in our startup class, we want to register our event processor interface and our event processor class. So after controllers, we'll put it in there. So using our services collection again, we are going to add singleton this time. And again, the reason we have to do that is because we are going to inject this class into our message bus subscriber class. So add singleton, event processor, and we're going to, let's bring in the namespace, event processing, and then we're going to give them an event processor, like so. All right, fantastic. So we'll save that off. Now what I might just do is I might just run this up, because stuff will often build fine and sometimes it won't run if you've done something wrong with dependency injection. Doing a .NET run really proves it out. So that's all looking good. That's still running up perfectly okay for the moment. So that is looking fantastic. So we're almost there. We're almost there. The next thing we're going to do is now create an asynchronous data service to listen from our command service on the message bus, and then it will use the event processor to add our platform to the database. So we'll do that in the next section. All right, so we are getting towards the end of our message bus stuff, and yeah, I do appreciate it's been a long haul. And the commentary I would want to make here is this is probably the most simple microservices application you could build. It's literally the most, this is literally the simplest one you could build if you're, you know, standing up in something like Kubernetes and using event messaging, and you can see how much work has just been involved in getting it to this stage, and we're still not finished, right? So microservices are really hard, okay? They are hard. They are not an easy thing. They are not a magic bullet. Now, once you have all this stuff set up and you're humming along, and then you're just responsible for building one service, and you've got all your libraries already, you know, all your packages, you're humming along, and you know how to subscribe and you know how to do this, then yeah, writing microservices is quite easy, but the entire setup and the learning curve is big, it's large. So not trivial stuff at all. So let's just clear all this down, make sure we don't have anything running, and we are going to create, I think this, no, it's not. I was going to say it's the final folder within our command service. It's not. We have one more after that as well. But yeah, for now, we are now going to create an asynchronous messaging folder for our subscriber. So async data services. Okay. And into that, we are just going to create a file, one file called message bus subscriber.cs. Now you're probably going, okay, we've been creating interfaces and concrete classes, Why are we just going straight for an implementation class? That's a great question. The reason is this service here is going to have to run in the background. We're going to start it when our service starts, and it's going to be continuously listening on our message bus for events. And so because of that, we have to build it in a slightly different way. We don't use the interface concrete class repository. Again, I did try building it that way, but you get into some very torturous tail chasing around service lifetimes and all that kind of stuff. So this is the simplest way of doing it, and you'll see how it will unfold as we start building it. But yes, we're basically building something called background service, and I'll put some links below that will explain a bit more about background services. But really, yeah, the whole point of it is that it's something that runs in the background. It's a long-running process, ideal for listening for events on a message bus. Now, a lot of this stuff is actually very similar to the client that we built in our platform service. This is the subscriber. A lot of the stuff is very similar to the publisher that we've already built, so it should look quite familiar. So I'm going to kind of go through that stuff quite quickly, and then the more interesting bits I'll call out in a bit more detail. So let's get started. Namespace, and it's command service, and we have to type this in as we've not used it before. So ASYNC data services, and it's a public class. Don't know why I capitalized that. I've not done that before. And we call it message bus subscriber, and it's going to, inherit from something called a background service. We'll bring in the namespace for that. First one here, Microsoft extensions hosting is the one we want. Now you can see straight away it's erroring out. Why is it erroring out? If we do a control period, then we need to implement the abstract class. Now this is this thing I was talking about, the long running task. Okay, so it's called execute async, and basically it's within here that we're just going to listen for events ultimately. Okay, that's the whole point of one of these background services. But before we come on to that, I'm going to create a constructor as usual. So CTOR message bus subscriber, and we are going to inject iConfiguration, as we want to get access to the configuration elements to know where our RabbitMQ instance is. So iConfiguration, we'll call that configuration. And then the other one we want to inject in is our event processor, which we took great pains at creating in the last video. All right. So we're just going to bring in the namespaces for this. So event processing, and assuming I've spelt it correctly, Microsoft extensions configuration. Again, please don't bring in the automapper configuration. And I might just put this on a new line as well. And let's get rid of that's better. Looks a little bit neater, doesn't it? Okay, so this is our class constructor, and as usual, we're going to assign these things to private fields and event processor. Okay, and then we'll just create those. So control period, read only field, and here as well, read only field. Now again, just to kind of labour the point about the event processor, we are injecting the event processor into this class. This class as well is going to be running as a singleton lifetime, so it's okay for us to inject in our event processor. It's a singleton lifetime as well, so it's fine to get injected. We couldn't, however, inject a repository. All right. So I'm going to actually create another method. We could put all our setup and connection stuff in here in our constructor. I'm going to actually just separate it out into a separate method just to keep things a bit more decomposed. But this is basically using the connection factory. You've seen all this stuff before, but we'll just do a private void, and I'll call it initialize. And I'm very conflicted about using Z's, but I'm going to go with the Americanized spelling, even though I don't agree with it. It's an international audience, so maybe it's probably more appropriate. So yeah, we're just going to do our connection into RabbitMQ from here. So you've seen this before, to be honest with you. So the first thing we're going to create is a factory. And that's going to be a new connection factory. And then we just pass in the attributes that we want, and we bring in connection factory actually, so we know what we're dealing with. So it's RabbitMQ client, and we'll specify the host name, and that just equals configuration. And again, you have seen all this before. I will just go back to our config file, either one, because these should be exactly the same name, and we'll just paste those in as before. And while we're at it, I will just come back over and I'll copy this in preparation for pasting it in as well. And I'll get rid of that so we have a bit more room. Okay, so that's our hostname set to that, and then we just set the port equal to underscore configuration, and we'll paste this in. Now again, it will complain because it's expecting an integer, so as before, we'll do an int parse. And we'll just run that off here and put the semicolon in, and that should be good. Okay, so that's our factory. We're then going to expect a connection, and that's just going to be equal to our factory create connection. So, and we don't have this as yet, and I think I've put 3 n's in. I'm getting overly excited because we're almost at the end of this. So control period and generate a field. There we go. And you can see it's added up here, private eye connection, all good. And then channel, and that just equals our connection, and we are going to create model. Again, we will generate that as well. It should add up to the top there. Yep, that's all good. And then we declare our exchange off of our channel. So exchange declare. And then here we'll specify the exchange, and we need to use, and in fact we should definitely move this into config, so we're not having it in here, but we'll leave it in there for the moment. So it's the same exchange as the one that we're publishing to, and then the exchange type is a fan out, and then we'll specify something called the queue name, and that just equals, this is slightly different than what you've already seen, queue declare queue name. And then we want to bind to that, and actually we have to create this first, so generate field. And then on our channel, we do a queue bind to the queue with underscore queue name. So it's somewhat dynamic, and we'll just take a new line because there's a few parameters coming up here. And we're going to, again, specify the exchange, which is trigger. And we do have to specify a routing key, which, as I said before, is kind of ignored. And I'll put that in the right place, that would be good. And at this point, we are listening on our message bus, so console right line, to bring in the namespace first, using system, right line, listening on the message bus. listening on the message bud. No, it's bus. Okay. And I'm going to do it anyway because I did it in the last one, so I'm just going to keep it consistent. We're going to subscribe to the connection shutdown method. So connection shutdown plus equals, and we'll say rabbit MQ connection shutdown. And we'll just specify that down here, I think under this, so private void. I'll just copy this. Specify an object sender and shutdown event args E. And I'll just do a console write line just to make us aware if this has been shut down. Connection shutdown. Okay, fantastic. And while we're at it, we'll just do some other housekeeping A-type stuff. We'll do public override void dispose. I also want to put in I'll do a check to see if the channel is open, then channel close, and connection close as well. Fantastic. And then just coming back up to our constructor, I just want to call this initialize method from within our constructor. So we'll do that here just before I forget, because that would be quite annoying if I forgot to do that. So all that leaves us to do really is put in the code in our execute async method, and we're going to do that. This video's been a little bit long, so I'm going to just take a quick pause and then we're going to come back and finish this off, and then we're almost ready, well we'll be ready to test asynchronous messaging end to end, locally at least, and then we have to deploy up to Kubernetes, but we'll do local testing first. So anyway, next section we'll finish off the execute async method. Alright, so let's come on to finishing off our execute async method. So let's just get rid of this for the moment. Now there's some kind of interesting stuff in here, all really based around this background service concept. So the first thing we want to actually declare is a stopping token, and we'll just throw if cancellation requested. So again, we can request that this method stops by passing in that token into here. Next, some RabbitMQ stuff. We want to declare a consumer. So just to reiterate, we've kind of created a connection, but now we want to actually start consuming events effectively on our message bus. So we'll say var consumer equals new, eventing, basic consumer. We'll bring in the namespace, which is RabbitMQ client events. Just take out that space. And we are going to pass in the channel that we declared as part of our connection. And then here's the magic. Here's the magic part that you've really been waiting for. So consumer, and then we will go to our received event, and we will subscribe to that event. And into here, we will pass module handle and EA. And you'll see how these are used in a minute. So large kind of lambda function. I'm going to do a console write line, and I'm going to say event received. Okay, so basically if this triggers, it means we have an event on the message bus that we've been listening on. Fantastic. So then I'm going to declare another variable called body, which is the body of our message, and that is going to be equal to the EA body, the EA input that we got here. All right, and then we want to convert this effectively to a string because it's a byte array at the moment. So I'm going to call this var notification message, and we're going to equal that to encoding, bring in the namespace for that, so system text, UTF-8, get string this time, not get bytes, so we're kind of going the other way, and then we'll pass in the body, and we will call the toArray a method on that. And then we're going to make use of our event processor from the previous section, and we're going to ask it to process the event for us. And we'll pass in the notification message that we've just kind of converted here. And that will determine what the event is. And then if it's a platform publish event, we'll add that to our database. And don't forget to put a semicolon here. Easily done. So again, we want to keep on consuming. So on our channel, we'll say basic consume. We specify the queue, which is queue name. Oh, that's definitely not right. So the queue. So underscore queue name. Auto acknowledgement. Now this isn't really something I covered, but you can also acknowledge messages. We'll say true. It doesn't really have any impact on what we're doing. And then consumer is the consumer. And then finally, we need to return a task, completed task. So this is again really to do with this long running task execution. We will return that at the end and save that off. Now I'm just checking through this. I think that is everything that we needed to do. So initialize, that's creating our connection effectively. This is our long running task, just waiting and listening for events. Our shutdown event is there if we want it, and our dispose method is there as well. So that is all looking good. Let's do a .NET build. Perfect. There's one last thing we need to do. We need to register this for dependency injection. So let's come back over, Control B, Control B to our startup class. And I'll just get rid of this for the moment. Now after controllers, we're going to add it. And the way you add it, this is where it gets quite interesting, services, and we're going to add what's called a hosted service. And we just pass in the name of our asynchronous listener. So it's message bus, actually I can't even remember, message bus subscriber. Bring that message, bring that namespace in. And we'll just round that out with a pair of parentheses. And that should be good. All right, so very, very exciting now. So unless I've missed something, that should be us ready to test locally. So we will run up our platform service and we'll run up this service and we'll actually see that it should connect in to our local, well, what it thinks is a local version of RabbitMQ, and it's listening, and then we will issue a platform create on our platform service, and we should see the event trickle down, and we should actually see platforms being added to our command service, hence completing the chain of pretty much everything we've been working towards this entire video. So I'm getting quite excited. We'll do that in the next video though. Okay, so the moment of truth, and I can tell you I'm genuinely nervous because there's so much kind of riding on this. So let's first of all come over to our platform service, and let's just do a clear the screen, and we'll do a .NET, let's do a build first. Cool, and then we'll do a .NET run. And again, just double remember, although we've been doing this throughout this course, that platform is running on 5000, but it can run on anything you like really, but just make sure it's running on a different port to our commands service. So platforms service we already knew was working, so that's no surprises. It's now really when we come over to our command service. Fingers crossed here. So let's do a .NET build. I will be so disappointed if this doesn't work. There's building, so let's see what happens when we run it. Straight away, I'm almost crying with joy, I'm happy. Let's see what we've got here. So this is the thing I was really wanting to see. We are listening on the message bus. So by registering our background service in configure services, we are starting that long running task, and it's now listening for events. So That's really good news. Now, what I want to do now is create a platform on our platform service using our friend Insomnia. I'm going to do this off screen, okay, because I want to capture and savor the moment and see what we get down here in our command service. So in 3, 2, 1, I'm going to create a platform in our platform service, and we should get the event down here on our command service. So 3, 2, 1, there we go. Fantastic. So first thing we get is our inbound post event, which we were getting anyway. That's our synchronous event. Next thing we're getting is an event received. So straight away, that's cool. Events are coming down. Then we're determining what event we got, and then we determined that our platform published event was detected. Now, I can't remember what other commentary we put in our event processing class. So let me just come over to event processing and select this. So let's just see when it determined the event, which it's doing here. Platform published event detected. I don't think we got that, did we? No, we did. We did get that. That's cool. And we return that, and then okay, there we go. We forgot to put in, that's a classic one, we forgot to put in add platform. So maybe that's a good thing, because everything else has worked correctly, we just haven't put in our add platform function. I'm just checking to see whether we didn't actually put in so that's quite good. Let's kill this. I'm happy so far, but I want to put in a console write line just when we add a platform. So we'll say platform added. Okay, so let's try that again. So we'll do a .NET run. And in 3, 2, 1, I'm going to create another event. So 3, 2, 1. Don't tell me. I don't think I didn't put in add platform again, did I? I forgot to do that again as well. Oh my God. Right. All right, I'm losing my mind. So let's put that in. You must be watching this and going, what is this guy on? It's been a very long video, so give me a break. So into add platform, we are going to pass over the message. Oh my goodness. All right, there we go. Let's give it third time lucky, as they say. So run. Looking good. And in 3, 2, 1. That's what we want to see. So platform event detected, platform added. That's looking pretty good. So I'm quite happy now. So let's come over to our Insomnia session, and let's come back to our commands service, and let's see if we can get any platforms on that service. And indeed we do. We get Docker. Fantastic. And so Docker's got an ID of 6. So let's just copy that, and let's see if we can create a command for the platform. So let's put in 6 in here, and that's Docker. So let's say, I don't know, push a Docker container to hub, and we'll just say Docker push, and we'll just put name of container, something of container. Fantastic. Oh, I've spelt it wrong, I don't care at this point. Let's send that over, and we get a 201 created. So we have, oh, this is good. I'm so happy at this point in time. It's been a long video. We have created a resource, a command resource with a platform ID of 6. And if we do, let's do a get commands for a platform. So let's do that. Send this over. There we go. So we're requesting all the commands we have for our platform number 6. And that looks like that is working. So if you've been following along this far and you've got the same result as me, congratulations. If you didn't get the same result, then again, we've been doing this step by step. So you should have been checking as you've been going along, and I'm sure you'll be able to find out what the issue is. Things I would personally check are the config settings are the first thing, and then again, just check the code with the code I've got up on GitHub. So that is really Good, I'm very relieved. So the last part of this section is going to be packaging up both our services and pushing them up to Kubernetes, and then we'll do this test in Kubernetes, and we'll do a bit more of an exhaustive testing to make sure everything's working as it is. But at this stage, it's looking pretty good. So we're now in a position where something gets added to platforms, it's event-driven down to the command service, and it has the events that our platform event has. But you'll be saying, wait a minute, our platform service already had 3 platforms in it, and all we got was the new platform that we added as part of our event-driven model. That's true. And we're going to come on and solve that in the last section. Once we've deployed to Kubernetes, the last section, we're going to look at resolving that issue. And to do that, we're going to use gRPC. All right, so just before we move on to the last section, which is on gRPC, we do want to rebuild both our services, rebuild their images, and push them up to Docker Hub. So I'm going to begin with the platform service. Make sure you're in the right folder. Quick directory listing to make sure you can see the Docker file. And then, as usual, it's a Docker build -t binary thistle, and then the name of the service, which in this case is platform service. Don't forget the build context, and we will build that up. And we will then push it up to Docker Hub. So I'm just going to take out the -t in the build and just push in platform service. Okay, brilliant. So while that's pushing up, let's come over to our command service. Do a quick directory listing, make sure you're in the command service folder, which we are, and we'll do a Docker build binary thistle, and the name is command service. And just note, make sure I spell it correctly, service. And just note, yeah, this is singular command service. The name of our project is command service. Our service name here is just command service. So we'll rebuild that. That looks good. And then we will push that up as well. So pushing will take a few minutes. So we'll give that, yeah, a couple of minutes. And we'll come back when that's happened, and then we'll restart both services. Okay, so our command service has been rebuilt, and I'll just pop over to platform. That's been, well, not rebuilt, pushed back up. Both of them are now pushed. So quick check on Docker Hub, just to make sure that they have been updated. So I'll just bring that over, and I'll just refresh it. We should see. Okay, so both of these were updated, yeah, a few seconds ago and 1 minute ago, so that is looking pretty good. Fantastic. So what we want to then do is we want to restart both our deployments. So clear the screen here. We'll do a kubectl get deployments. And we already have deployments, so that's why we're not doing the kubectl apply, we're doing the role restart, because we already have these deployments. And again, if we did an apply, kubectl apply deployment file, the deployment file hasn't changed. So again, I've said that a few times already. So let's just redeploy the platform service first. And we'll do a test on that. So kubectl, rollout, restart deployment, and we want to do platforms deployment. So we'll copy that, we'll paste that in, saying it's restarted. So clear the screen, and we'll do a kubectl get pods just to see. So we've got the container creating state, which is fine. So we'll just have to wait for that to create itself. And then what we'll do is we'll create a platform using Insomnia, and we'll see if it drops an event onto the event bus. Just make sure that part of the equation is working, and then we'll redeploy our command service to check that it receives events successfully. I just want to do one leg at a time rather than trying to do everything at the same time. Cool, so that's all running now. That's looking pretty good. So if we come over to Kubernetes, here we are. I'm going to do a sort by started time. So we should see our platform service at the top here. Looking pretty good using SQL Server, applying migrations. We already have data. That's all looking fine. Good. So we'll then pull over RabbitMQ management console so we can take a look at messages going on to the message bus, hopefully. And then the final thing I'll do is I'll just use Insomnia to create a new platform on our platform service. So let me just bring Insomnia onto the screen. The screen's getting a little crowded, but that's okay. So here's our K8's environment. Here's our platform service. I want to just see what platforms we have in here. Now I added a few just while I've been testing offline. We've got a few more platforms in here. That's okay. I want to create a new one. So I'm going to create a new platform. Let's create one called console. I think that's how it's pronounced. It's a service mesh application from the same people that make Terraform. That's all good. So what I'm going to do is I'm going to click send. Okay, and we've got a 201 created. Let me just get all platforms, make sure that was created. Yep, that was created. Good. And over here, we were successful in sending a synchronous post to our command service. We then move on to the asynchronous stuff. So RabbitMQ connection is open, we're sending the message, and we actually did send a message with our attributes onto the message bus. And we can also see down on the message bus that yes, indeed, a message was sent down. So that's excellent. That's our platform service working in production. So I think all we need to do now is just redeploy our command service and see if it receives events. So let's do that now. Now you can do a restart in any terminal. It doesn't have to be within any particular project. So I'm just going to do a clear the screen. I'll do a up key. I want to get all my deployments. So we want to restart the commands deployment now. So I will do up key, and then we'll replace platforms with commands. And that should restart our commands deployment. Okay, and we'll do a get pods, and we'll see that we've got our commands service in the container creating state. So we'll just wait for that to create, and then we'll run a very similar test, and hopefully we should see not only events going on to the event bus, but the event being received in production, and then we can also query that service as well in production. So I'm just going to do a quick check to see how our pods are getting on. Yep, the other one is terminating, which is good. There we go. So we've got all pods, all 4 pods running. That looks good. So what I might do is come back over into Kubernetes. Let's bring that onto the screen. There we go. And the problem here is I have 2 screens and they're running at different sort of magnification, so the rendering can be a little bit weird. Anyway, let's order by start time. So again, command service is the newest one. So that's really good news. You can see it's listening on the message bus, which is excellent. So it's started up and it's listening. So what I might do is just come back over to Insomnia, and we'll create another platform. So let's create another one of the HashiCorp applications. They do something called Vagrant as well. So let me just move this down a bit. Click send. There we go, looking pretty good. So we got an inbound post from our synchronous service, which should be working anyway. We also received an event on the event bus. We determined the event. We established it was a platform published event, and we added a platform to our in-memory database. So that all looks like it is working exactly as we would expect. And you can see here that we had that event placed onto the message bus. So looking pretty good. So the only thing that we should really do is add some API calls for our command service. We don't actually have any yet. So in our K8s folder, I'm going to create another folder, and I'm going to say commands service nginx. And we want to, let's see what commands we have. Let's get platforms, that's the one we really want to check. So let's do, actually we can probably copy it from down here. So get all platforms, let's duplicate that. And we'll move it into, move it a bit further up, move it into here. And all we need to do is change the URI. And again, we want to make sure that we put the correct route in. Oh, I copied the wrong thing, I think. No? This must be very painful to watch. Let's copy that. Let's paste it back in here. Okay, and it's API/C get platforms. There we go. So we have our one new platform created in our command service, and of course we don't have the other commands yet because we're only working off an event-based model at the moment, but we will come on, we will rectify that with gRPC. We'll use that to pull down any other commands that way, but that looks pretty good. So maybe what we should do is add a couple of other endpoints in here. Let's create a command. So I will come down here and duplicate this, create command for platform, and we'll just move it up to here, and it will be the same. No, actually it won't be the same, it'll be slightly different. Let's copy this, let's paste this in here, and let's just check what this platform was, 8. So if we come over here, you want to put in 8 and then commands, and that should create a command for that particular, and we'll just leave the same body and it doesn't really matter, but we have created a command there for that particular platform. Good, and we'll just duplicate one more request. Let's get all commands for the platform. Let's just duplicate that just to make sure that's working, and we'll move that up to here as well and move it into the right place. So again, we'll come over here and we'll copy this URL and we'll paste it into here. And I think that's a GET request. So we're getting all commands for this particular platform. There we go. And we've got our one command that we just created. So that is all looking pretty good. I think we can draw a line under Kubernetes stuff really well. Yeah, we can draw a line under the Kubernetes stuff. We don't have to create anything else in there. We can draw a line under event-driven stuff. We are pretty much done with that. Now, obviously, we have just started using an event-driven model. We now have the fabric set up to send events both ways. Well, you'd have to kind of put the client in and the subscriber in each class if you wanted two-way communication, but we've got basically everything we need to work with event-driven models. So that's great. So the last thing, that we want to come on to is we're going to move back to synchronous messaging now, and we're going to address this final problem that, okay, cool, every time a new command is created, we push it down to our command service. Sorry, every time a new platform is created, we push it down to our command service, but we still have the issue where we don't have all the commands. So we're going to solve that in the next section with gRPC. All right, so we move on to the final section of the video, and we're going to be talking about gRPC, and not just talking about it, we're going to develop some gRPC code. But before we move on to that, as it says on the screen, let's discuss what it is and why we should use it, or why would you use it. So first of all, it stands for Google Remote Procedure Call. So obviously created by Google, but it's now again in the public domain in the same way that Kubernetes is as well. It uses the HTTP2 protocol to transport binary messages, and that's quite important. It's, binary messaging. It's designed to be very lightweight and highly performant. I've also put in brackets here because this is something that we're going to discuss in a bit when we come on to implementing it. It does require, or usually does require, the use of HTTPS or TLS, whatever you want to call it, as part of that connection. Now, we are not using HTTPS or TLS internally within our Kubernetes cluster. So that does mean we have to do a little bit of a workaround to get gRPC working, because it is kind of usually reliant on that. As it says they are focused for high performance. It relies on something called protocol buffers, or protobuf, which effectively defines the contract between the endpoints. So you use this protobuf file, which defines the service. It defines inputs and outputs. And this protobuf file exists at both endpoints, both the client and the server, and it really forms the contract that both parties have between each other. As you would expect, it's multi-language support, so yeah, we're obviously using C#, but if you have a C# client and a Ruby service, they can talk together using gRPC. And there's language support for most of the main languages out there. It is quite frequently used as a method of service-to-service communication, so you wouldn't typically have a client web browser using gRPC to talk to a service, just given the complexity of the HTTP2 protocol and gRPC itself. So it is used really just internally for service-to-service communication, but it is still asynchronous messaging methodology, if you like. So here's a bit of a diagram. So yeah, we are not implementing this obviously, but yeah, we have as an example, a C# client on the left with the proto file, and then we have a Ruby service on the right, again with the same proto file definition. They talk via HTTP2, and yes, our client has a gRPC stub on the left, and our service has a gRPC server on the right. Now, one of the things with gRPC when we come on to using it within our applications is there is a lot of generated code. So we write a proto file, which is actually relatively simple, very small. As part of the build process, the gRPC library actually builds up a lot of stuff in the background that allows it to work. And then we work with gRPC to actually make calls and receive requests. So we'll see how all that works in the next section. Now, just before we move on to the code, I do want to just come back to our solution architecture and just kind of round it out, because we have been sort of checking in with this as we've moved along. So we are basically at this stage now. We have both our services. We have HTTP communication between the two. We have publisher-subscriber event-driven messaging between the two, both in development and in production. And now finally, what we're wanting to do is introduce gRPC. And our use case is that when the command service starts, we want to use gRPC to reach out to the platform service and retrieve all the platforms that the platform service has. So it gets around this issue of the fact that we only have, at the moment, the event-driven platforms that the command service is aware of. With this gRPC last bit, command service is going to reach out at startup and pull, using gRPC, all the platforms down, and it will load the ones that it doesn't already have. So that's our use case, and that's what we're going to implement in the next section. All right, so we'll move on now to implementing our gRPC stuff. And I just want to be clear, because maybe I've not been totally clear about the server and client model here. So in our scenario, the command service is the client, and it reaches out to the platform service, which is in this scenario considered the gRPC server. So at startup, command service is going to reach out and pull down all the platforms that the platform service has. So the server is the platform service, and the client in this scenario is the command service. Now, I also realized I did lie to you in the last section when I said that we had finished all our Kubernetes stuff. That was in fact a lie, not an intentional lie, an unintentional one. I just simply forgot that there was one small piece of config that we have left to do. And it's very, very small, so you don't need to worry too much about it. And it's really just an addition to some existing config that we have. And for those of you keen of eye, you'll actually see on screen here the addition that we still have to make. And that is around, really, our cluster IP service and the fact that it needs to provide a port called 666. And what is that port? Well, I'm just using the number 666. It can be absolutely anything you like. I'm just using it as a little bit of a dark humoured joke, mainly because it took me a while to get this stuff working. And what we need to use it for, I did mention that gRPC uses HTTP2 with TLS, effectively HTTPS. Now, we don't have HTTPS running in our cluster, and it was one of the things I decided to leave out because there's quite a lot involved. Number one, to get it up and running in a cluster, and number two, there's a lot of opinions that you don't really need HTTPS inside your cluster because it's kind of an internal domain. You would terminate TLS at the Ingress Nginx gateway. So certainly from your web browsers to your services up to the gateway, yep, use HTTPS, absolutely 100%. Inside your cluster, there's differing opinions. Some opinions even suggest you don't even need to use it. So it's why I decided to leave it out. There's a lot of work involved to get it set up and generating certificates, even development certificates, so I've left it out. So with that being said, that left us with a scenario where we're not using HTTPS, we're not using TLS therefore, and so gRPC needs that little bit of extra config in order for us to tell it that we only use HTTP2 protocol without TLS. So in order to do that, we need to do some configuration on the Kestrel web server running on the platform service, which is our server. And then we tell our client endpoint to connect in to a specific port, in this case 666, that we allocate, that is just running HTTP2 without TLS. When a client connects to a server using gRPC, there's a negotiation that happens and they will use the highest level of security available on that connection. And so if we don't explicitly say there is no TLS, it will attempt to use TLS as a connectivity method and it will fail because we just don't have it set up to work correctly. So it's a little bit of a workaround, but in some ways it's not a workaround, because if you don't want to use HTTPS in your cluster, you would have to do something like this anyway. So that's what we have to do to get it all working, simply because we don't have HTTPS running in our cluster. So a very small bit of config in Kubernetes, so we'll do that next. And then we'll move on to configuring the Kestrel web server, which we'll do via config. And then we're ready really to move on properly to the gRPC stuff. But this is a bit of networking stuff that caught me out. So we need to get it done and out of the way. So back over in our K8s project and back in our platform's deployment YAML file, all we need to do is add another port to our cluster IP service. So the actual deployment does not change. This stuff does not change. All we need to do is add another port. So in the file, underneath ports, we'll add another array element. We'll give it a name. You need to give it a name, and we'll call it platform gRPC. And we will give it a protocol, which is just TCP. And we'll give it a port. Now this port number can be anything you like. If you don't feel comfortable using 666 for various reasons, you don't need to use it. You can use anything else you like. I'm just using that, given my sense of humor. And then target port is also 666. And that's it. Save that off, and then we need to basically apply this deployment file. So it's not a rolling restart, because our actual file has changed. So we need to apply it. Again, I keep laboring that point of difference. So we'll do a quick, let's get our services. So kubectl get services, just to have a look, and I'll just move this over. That looks horrible. And you can see here our platform's cluster IP service, excuse me, is just running on port 80. So we want to additionally add our port 666. So to do that, let's do a directory listing and get the name of our file. There we go. And we'll do a kubectl apply f, name of our file. Make sure I pick the right one. Copy that down, paste that, and what you'll see is that our deployment itself is unchanged, which is correct. We didn't change any of that, but we did change the cluster IP configuration, and we can see that it has a configured status. So if we do get services one more time, you should see now on our platform's cluster IP service, we have this additional port that it's listening on. Fantastic. So I'll just pause here for a minute, and then we'll move over into our platform service project, and we'll do our Kestrel configuration, and then we're ready to move on to actually using gRPC. All right, so back in our platform service, and we only need to do this in the platform service. We don't need to do it in the command service, the client. We only need to do it in the server side of things. And the other thing I'll mention is this is a configuration for when we're running in Kubernetes. When we are running locally, doing a .NET run, HTTP is supported, so we can actually, you don't have to worry about this, it will just work. All right, so what we want to do is, I'll just get rid of this for the moment, and I'll close down all these files because it's taken up a bit of room. And we want to come into our production, our app settings production file. Okay, and this one here. So again, make sure you're in platform service, app settings production JSON, and we want to add in some configuration into here. And so we'll add it under our RabbitMQ stuff, so comma. We're going to nest some attributes in here. So as you can see here, VS Code is kindly providing some defaults. So it's the Kestrel web server we're wanting to work with here. So I'll bring this onto a new line. We then want to specify endpoints. You can go, it's actually giving us some help here. Within endpoints, we want to specify a label, effectively. So the first one is going to be gRPC, and then I'm going to provide some more curly brackets. So let me just bring these onto new lines. My eyes cross slightly when things aren't indented properly. So gRPC. We then want to specify protocols, and then we want to specify for this HTTP2. Now that just allows us to use HTTP2 with no TLS. And then we provide a URL. And again, it's a production URL. So this is basically the URL that the server is going to be running on. So it's going to be HTTP, not PS, so make sure it's HTTP. And what is the server that we're running on? Well, we've come back again into our K8s folder project, and we come down to the name of basically our cluster IP. So in production, this is the URL of the server that it's going to be running on. So we copy that, come back to our platforms file, platforms project, we paste that in, and we put 666 on there as well as the running port. Okay, so just go through that again. We're configuring the Kestrel web server. We're configuring a number of endpoints. That looks a wee bit weird, so I'll take a new line. We're calling this endpoint gRPC. This can be anything. And then inside this particular bit of config, we're specifying the HTTP2 protocol and the specific URL that we want. Now we need to actually now explicitly specify as well just the web API or the HTTP endpoint for our HTTP services, which have been running on port 80 thus far. And so that's all we're going to do. We're just going to specify that it's running on port 80. So again, protocols. This time we're going to select HTTP1. And then finally the URL. As before, I'm just going to copy this up to the colon. Exactly the same. Paste that in, and it's port 80 this time. All right, so that all looks good. I'm just going to bring these commas up here. Make it a bit consistent. That looks a bit better, doesn't it? Yep. This must be quite painful to watch. In fact, if I do an Alt-Shift-F, yeah, that does it for us. There we go. So Alt-Shift-F auto formats it for us instead of me clicking about like an idiot. So yeah, we've got two endpoints. One, this is basically what we already have, and this is the new one that Kestrel will now listen on, and we're telling it just use HTTP2 without TLS. So we'll save that off. Fantastic, and that will only be applied in production. Now I do want to just check, come into launch settings JSON, I do want to check that we're still using, yep, so we're still using HTTPS 501 in local development mode, but I'm doing .NET Run, that's fine. And I might just come in quickly while I remember in our command service, just double check in properties as well, check launch settings JSON, and again, we're running HTTPS there with the local development certificate, so that is all fine. All right, so a little bit of faffing around there. That's a bit of networking stuff that caught me out when I started deploying this into production, but we should be good to go now. So in the next section, what we're going to do is we're going to move on to more interesting, actual proper gRPC stuff, and we're going to specify our proto file. And our proto file basically specifies what the service is and what the shape of the data is. And then we'll do some build that actually auto-generates a lot of code in the background that we don't actually alter, but is auto-generated from this proto file. So we'll do that next. All right, so before we actually even get started with coding, we do need to add some package references to both our services, to both our platform and our command service. So let's come back to our platform service first, as it's slightly simpler, would you believe? It is the server in this scenario, but we only have to add one package here. So bring up your command line, and I might get rid of our sidebar, Control B, and I'm going to do a .NET add package, and the one we want is gRPC ASP.NET Core. And that's the only package that we need for our server. Okay, so again, our platform service is acting as a server in this scenario, so that is the only one we need there, so that's cool. Then let's move over, while we remember, otherwise I will probably forget, let's move back over to our command service project. Now this is acting as the client. Now, surprisingly, or maybe not surprisingly, we need to add quite a few package references in here to support gRPC from a client perspective. So we'll just add those in one by one, clear the screen, and so the .NET add package, and the first one we'll add is gRPC tools. Okay, and that's added that in here. The next one we want to add, I'll just do an up key, add package, gRPC .NET .client. And that's added that in as well. And then the last one is a Google package, is Google.proto buff, which is protocol buffers. Fine, so those are the three packages you need in the client: Google Protobuf, gRPC.NET Client, and gRPC Tools. Fantastic. So we've got everything we need from a configuration perspective. Now let's move on to constructing our proto file. All right, so we want to come on now and create our proto file in our project. So we'll just close this stuff down. And yes, in our platform service, we're going to create another top level folder called protos. So new folder, call it protos. And then I'm going to create my file, and I'm going to call it platforms.proto. Like so. All right, get rid of the terminal, and I'll do a Control B to give us a bit more space. So it's in here that we define our contract effectively and what will get passed between server and client. So some syntax setup. It's kind of similar to the stuff we did with Kubernetes, specifying API versions, but this time we specify the proto version, so proto version 3, semicolon, and then we specify the C# namespace, which, let me just double check, so Control B, we'll just pick any class at random, and it's just the top level namespace, so in this case platform service. So we'll copy that into here and put that in here like that. Okay, fantastic. So yep, that's just kind of general setup stuff. So the proto file applies to this namespace, and that will be used later when we do some building and code gets generated. So proto file will consist of the data, the messages that gets passed in and back from our services, and that's the other thing. We define our remote procedure call services in here. So I'm going to define the messaging first, and you do so by using the message keyword. So the first thing I'm going to specify is our input. So again, just to reiterate, this service is going to allow our client, our command service, to retrieve all platforms. So what input does it supply? It doesn't actually need to supply anything. So we still have to specify an input. So I'm going to call it get all request, and it's just empty. Okay. And then what do we give back? Well, we're going to give back a load of platforms, assuming some exist, which hopefully they do, but that's what we're going to give back. So what we're going to specify now is effectively the platform model, the structure of that. So I'm going to call it gRPC platform model. And you can almost think of this almost as analogous to a platform model definition, a C# model definition. It's almost the same as that, really. I'll just come back up here and do our curly brackets. Now, we're going to effectively now specify the properties of our model. Now, you define them in a protobuf file in a slightly different way. We specify the data type. And the first one I'm going to define is the platform ID. So I'm just going to call it platform ID in this instance. And I'm going to make it equal to 1. Now, your first question, if you've not done this stuff before, is why are you making it equal to 1? The 1 in this case is not a value of platform ID. The 1 in this case is a position number. So for every property you define, you've got to define its position. It's just how protobuf files are defined. So that's it. And again, bear in mind, the messaging between services is totally in binary. So again, it's all part of that encoding process, which personally I'm not going to get that involved in. The next one we're going to specify is the name. It's a string, and we're going to make its position equal to 2. So you can kind of see a bit of a pattern emerging here, and then finally we'll pass over another string, which is the publisher. And no guesses as to what position we're going to give it. We're going to give it position 3. So to be honest with you, this actually isn't the data that we pass back. We want to pass back multiple, potentially multiple platforms. So in order to specify that, we have to specify one more message, and we're going to call it platform response. And this is actually what we pass back. And we want to pass back many of these, multiple of these. So the way you do that is the repeated keyword, and then the name of the model that's being repeated, and then we just give it a name, platform. And we have to again specify a position ID in that message payload. Okay, so if you've not done it before, maybe it appears a little bit strange. I guess, you know, it's not fair maybe to say it's strange. It's just if you've not done it before, it's probably not that familiar to you. But the most important takeaway here is we're going to be referring to this kind of as our model, our main platform model object, and we're actually going to be doing some automapper stuff with this eventually. Now, something to really call out, which I find, again, a bit counterintuitive for me, is when we build this project, the gRPC package will actually create code for us, and it will actually create a model, a gRPC platform C# model for us. That doesn't exist as yet, okay? It exists here in this format, but it doesn't exist as a referenceable C# model. It will eventually when we do our build, but there's a few steps we need to do before we even get to that. So we're not quite finished the proto file though. We need to specify the actual service itself. So our client is going to call this service to get back these platforms. So we define that by defining service, and I'm going to call it gRPC platform brackets, and then the remote procedure call itself is going to be get all platforms. And then we supply the inputs. So this is basically this is the procedure call here that we're defining, the method if you want to call it that. So what are we inputting to that? We're inputting this, expecting that as an input, which is basically just an empty object, it's nothing. And what do we return? We return this platform response, which is a repeated array of models, or collection of models, however you want to term it. And we put it in parentheses like that. So that's our platform's proto file done. Let's just save that off. And again, this is the contract between our server and our client. And we're going to copy this file eventually over into our command service as well. It's going to have exactly the same copy of this so it knows how to talk to our server. Great, but we're not quite done with our setup. We need to add something to our CS proj file so that when we do our build process, we get some code generated. We then need to define our actual our synchronous data service that makes use of gRPC, and then we need to update our startup class to pull all this together. So there's still quite a bit to do, just setting up our server, and then we'll come on and effectively repeat the same thing in our client. But next, let's update our platform service CS proj file, and then we'll move on to actually defining our service. All right, so let's go over to our CS proj file, and we need to specify a new item group. All right, and I'll just copy that, and I will terminate that off. I'll paste that in, and we'll terminate that. Usually, I found usually this kind of helps you and auto-completes a wee bit for you, but maybe it's not being that helpful today. Anyway, so what we want to define within our item group is something called protobuf, and this is basically telling our project where it can find a gRPC protobuf file. So protobuf 1f include equals, and it's just a path to our protobuf file. So it's platforms.proto. And then the other thing we want to specify in here is whether our platform service is running as a server or a client. And as you know, we're running as a server in this instance. So we just say gRPC services equals server. Terminate that like so. So let's save that off. So yeah, again, this is really just saying we can find our platform's proto file, and when we do a .NET build, we're going to get some automatic code generation going on, which can take a bit of getting used to. I don't personally like it, actually, but it's how it works, and I understand that's why it has to work like that, but I don't really like code being generated on my behalf. But anyway, that's how it works. So let's give that a go then. So control backtick, and we'll do a .NET build. Okay, and all being well, that builds up. So what should have happened if we come into our OBJ folder, into debug, you'll see we have this protos file, and then in here we have our generated code, and you can see by the code window over here, it's quite voluminous code. Okay, there's quite a lot going on here, and that gets generated for us every time we build our project. So you don't touch that code, that's just done for you. And you know, fair play, all you really need to specify is this protobuf file, and the rest gets taken care of. But just be aware that there is that auto code generation going on. And if you haven't done a build and you try to access this class, for example, you'll have some trouble with it. But that is there now, having generated it. All right, fantastic. So that's us just set up the protobuf stuff. What we actually need to do now is create a synchronous data service that is going to act as our server effectively for our platform service. So we'll do that next. All right, so back over in our platform service, let's just clear this stuff down. We are going to come back into our sync data services. So you'll remember that we had defined some HTTP sync data services. We now want to create another folder under sync data service called gRPC. I'll capitalize the G. All right, and into here we're going to create our server, basically, our gRPC server. So right click, new file. I'm going to call this gRPC platform service .cs. All right, so namespace as usual, namespace platform service, sync data services, and then we're going to add gRPC onto that because it's newly created. So it's a public class called gRPC platform service, and then we're going to inherit from gRPC platform gRPC platform base. And coming into our protos file, you'll see that that looks familiar. Okay, that is our service, the name of our service that we are kind of inheriting from. Now, we got autocomplete there because we'd already built our code. If you hadn't built our code prior to writing this, you wouldn't get that. Probably not, unless you've got the automatic build stuff going on. So again, just be aware of that. All right, now ultimately, we are going to be making use of our repository because we're wanting to go into a repository, get all our platforms, and then pass back this protobuf class. What's it called? Platforms response class. So we come back into platforms response. We are wanting to pass that back, basically. So you're probably starting to think, okay, we're going into a repository, we're going to pull out some platform models, we're going to be passing back this gRPC model type. We need to map those, and indeed we do need to map them. So just before we complete our service, I'm going to come back over to our profiles folder, into our automapper profiles, and I'm going to create one final profile in here. So create map. What is the source? The source is going to be our platform model. So we're going into a repository, we're pulling out platform models. Okay, what are we mapping to? What is our destination? Our destination is gRPC platform model. Okay, so back over in our protos file, it's this here. This is what we're mapping to. Okay, so we have to map our attributes effectively. Now, the only one really that we need to map is this one here, because I've called it platform ID here, whereas in our model, it's just coming back as ID. So let's do that now. So we've seen this before. So for member, destination, so what we're mapping to. So this is the gRPC platform model. we are mapping to platform ID. Now you can see here that the code generator has changed platform ID into the standard C# capitalization. So we get capital P, capital ID. You'll remember in here, it was all, well, it was a different case. All right, so it's done that for us. So we're now working with our C# type class, the generated class. So we want to map to platform ID. What do we want to map from? The source. So OPT. Let me just get rid of the sidebar there. So OPT goes to OPT. What do we want to map from? Well, in our source, SRC goes to SRC, and this is a bit long-winded. Then, it's our ID. So our platform is our source. We want to map the ID of our platform to the destination, which is the platform ID of our destination. Now that's all we should have to specify because the other names are similar, but just to be totally complete, I just want to do the other mappings for the other attributes just in case we get caught out. You shouldn't need to do that though because they are basically the same. So in our destination, we've got a name. What do we want to map to? We want to map to name. Okay, so really don't really need to do this, but because we've only got a few, I'm just putting it in just for like complete safety, just in case we run into any issues. But these last two shouldn't be necessary. We should be able to run without them. Okay, this is the first one. The first one is the only one we really need to do. And don't forget, semicolon. So again, that is the last mapping, auto mapper mapping we're going to have to do. So we're mapping our platform to our gRPC model. So going back over here, let's finish off our class, our platform service. So I'm going to do a constructor. And into our constructor, I'm going to pass our repository. So iPlatform repo. I'm going to call it repository. And we're all going to pass in a mapper object as well called mapper. And we'll assign those. Actually, let's bring in the namespaces for these. So data service and auto mapper. Fantastic. And so pos underscore repository equals repository and underscore mapper equals mapper. We'll generate read-only fields for those as usual. So that means we now have access to our mapper and also our repository. So we've seen this 1,000 times before. And then we come on to actually exposing the method that is going to allow us to return our platforms back via gRPC. So public override synchronous, so task. And what are we returning back? We're returning back platforms response. So again, in here, we are returning this back. Okay, that is what we are returning back. And again, our platform's response is an array of these. Okay, so it's not the most intuitive thing, to be really honest with you, and you're maybe scratching your head a little bit. I really don't blame you, but bear with it. It does all work. So we're going to call this method getAllPlatforms, and then we're going to specify getAllRequest. Request. Again, that is this thing here. And finally, we have to specify this other thing here called server call context. And we'll just bring in the namespace for that, gRPC core. That's a gRPC specific thing that we have to specify in this method. All right. So task, I think we need to bring in the namespace for threading. Yep, that's all good. So this is just complaining because we've not returned anything back yet. So I'm going to create a new platform response object. I'm going to call it response equals new platform response. And then we're going to use our repository to populate another variable, platforms, with a bunch of platform models if we have any. So I've seen this before, using a repository, get all platforms. All right. And then we want to basically add each of our response models, each of our platforms, to this platform response object. So I'm going to do that via a for each loop. So for each variable, call it platform, in platforms, so for each model in our platforms collection, on a response object, which is this platform response object here, platform add, and then we're going to use mapper, increasingly becoming my favorite tool. And what are we mapping to? We're mapping to a gRPC platform model. And what is our source? Our source is plat. All right. And then finally, we return task from result here, response. And that should be our service good to go. So we'll save that off. So yeah, basically we're making use of a repository, we're making use of our mapper through constructor dependency injection, and we are returning back a platform response object, which again comes from here. And we're basically doing that by using AutoMapper to populate that collection using a for each loop. All right, so that's our last use of AutoMapper in this service anyway. It's served us very well, and yeah, we're basically almost at the end of the defining the server related stuff for gRPC. All that we need to do now in this next bit is come back into our startup class and actually register this service for dependency injection. We also need to specify, actually we need to specify it as an endpoint, not dependency injection. We do need to register gRPC more globally for dependency injection, and we specify this as an endpoint in our configure method. So we'll do that next. All right, so almost there with our server. So let's bring up our directory browser, and I'm going to come into startup. Let me just go to this other stuff and close that down. And in configure services, we do need to register gRPC for dependency injection. So services add gRPC. That's it. We don't take those out. We don't need to do anything else. Let's save that off. All right, but what we do need to do, which is a bit more kind of involved, is we do need to specify the service that we've just defined, the server that we've just defined as an endpoint, which kind of makes sense, I think. So under our controllers mapping, we need to specify endpoints again. And this time we're going to map gRPC service. And what service are we going to map? Well, the service that we just created. So let me just bring that up, and we are referring to this service here, our gRPC platform service. So I'm just going to copy that and paste that into here. As so. And we need to bring in a namespace for that. So using platform service sync data services gRPC. Fantastic. Now this next bit is optional, and I'm going to put it in just for completeness. Now this is what this allows us to do. This allows us to serve up the proto file to a client, and they can then use it and understand what the contract is. So you don't need to do this bit, but I'm just going to do it for completeness. So endpoints map get. And we're going to specify a path, and I'm going to say protos platforms.proto. And we'll say async, S, Y, and C, context, pair of curly brackets, let's put in our semicolon. And in here, we're going to await context. Response, not request, response. Write async. Bring in that, and then we will do system IO. I might actually take this out and just have file. We'll bring in the context using system IO, that's better. Read all text, and we'll just specify what we're wanting to read, which is protos folder platforms.proto. So again, don't need to do that. We're just adding another endpoint to serve up our contract, which is probably good practice. All right, so let's do a .NET build. All good. Let's do a .NET run. All good. So again, not really doing much at the moment. We do need to move on to doing our client to make requests to this to see if this all actually works. But the fact it's not crashing or doing anything horrible at that, I think we're probably in quite a good place. So now we're going to move on to writing our client in our commands service. Do that next. All right, so we have just completed the gRPC stuff from the perspective of our platform service. So we'll just stop that running if you had it running. And now it's time to move over to our command service, which is our client. So we're going to do a lot of the same stuff, but there are going to be some differences as well. Now, just make sure before you continue on that you added these 3 packages to the CSproj file in the commands service. All right, so the next thing we want to do is we want to add some config. So when the commands service starts up, we want to tell it where to go to retrieve our list of platforms. So we need a destination basically. So we'll need one for development and we'll need one for production. So it's just really the URI of the endpoint of our platform service endpoint. So over in our command service, I'll close all this down. And we'll go into app settings development JSON first. So along with all our other development endpoint config, we will create one last piece of config and we'll call it gRPC platform. And we'll give it a value of our platform service endpoint. So HTTPS. Now note that I'm using HTTPS in our local development environment. That is supported. So localhost port 5001, and that means we don't need any additional config. That will all just work out the box. Fantastic. So I'm going to copy this and then come over to production settings. And this is where we want to target our production endpoint. Now, as we have already gone through, we cannot use HTTPS. And then we just need to find the endpoint of our production server. And so as before, let's just come back to our K8s project, come back to our platforms deployment file, and you'll see again, this is the name of our server. So we'll copy that, cluster service IP, and we'll bring it back over here and we'll put that in here. And then the only other thing we have to put in is the port, or gRPC port, which in my case is 666. So when this starts in production, this is the endpoint we'll try and target. And when it starts in development, we'll just access our local host on HTTPS. And note that this is HTTP. Make sure that you put that as HTTP. Fantastic. So that's it for the sort of configuration setup for our client. Next thing we'll do is we'll just copy the proto file over from our platform service into our client service. So we'll do that next. All right, so let's just close this down and we will create a folder in the root of our command service project. So right click, new folder, and we'll call it protos as before. And then rather than, well, what we'll do is we'll create a file and then we'll just copy the contents over. So new file, and we'll call it platforms.proto. And then we'll come back to our platform service, get rid of that, and find our protos folder, platforms proto, and we'll just copy all of this. It's exactly the same. And we'll bring it back over and paste it in here. Fantastic, so we'll save that off. Now, like with our platforms project, you will remember we had to put a line in here to define where gRPC can find any proto files. So I'm going to copy that as well out of our platform service CSproj. I'm going to copy that and back over in platforms, back over in commands. I'm going to paste it in here. Now, the one thing that we will need to change is this. It's not running as a server, it is running as a client, which shouldn't really surprise you, but everything else remains the same. The route or the path to our proto file is exactly the same. So let's save that off. All right, let's do a .NET build. Let's go back to our console, back to our terminal, should I say. Clear that and do a .NET build. And everything looks okay, that's cool. All right, so with that done, all we really want to say is there's a few more things we need to do, but the next thing we're going to do is actually build our client service that's going to be called to call our server endpoint. So we'll do that next. All right, so back over in our command service, we're going to create our client, our synchronous client, to connect in and make a call to our remote procedure call over on our server. So back in our project, we're going to create one more root folder called sync data services, because again, gRPC is a synchronous data service. Now we're not creating any more other than gRPC, but just to keep it consistent, I'm going to do a new folder and create gRPC, just in case you wanted to add a HTTP client here as well to make other calls. We'll just structure it in a consistent way. So we're going to create an interface first. So in the gRPC folder, right click, new file, and we're going to call this platform data client.cs. So the namespace, command service, sync data services, gRPC. And it's just a public interface called platform data client. And what we're going to get it to return, we're just going to get it to return an enumerable of platform objects. And we'll call it return all platforms. So we'll ultimately run this at startup. So let's just bring in our few namespaces. So we'll bring in, I think I've spelt that wrong. Yeah, it's better. It didn't look quite right to the eye, so there we go. And we'll bring in our models as well. Fantastic. So you're probably starting to think, okay, we're going to be using a gRPC client to ultimately return a list of platform models. So you're probably starting to think we need to use AutoMapper. We do, but we'll come on to that in a bit. But for now, this is sufficient for the moment. So we now want to create a concrete class. So right click the gRPC folder, new file, and we're going to call this platform data client.cs. I'll get rid of this and I'll give us a bit more space here. So namespace, command service, sync data services, gRPC, and it's a public class called platform data client. At least I think that's what we called it. Let me just double check. Platform data client, yes, that's fine. And that's going to inherit from our interface. So cursor in there, implement interface. But before we do that, we're going to create a constructor. And into that, we're going to pass configuration, as we'll read in the endpoint from our configuration file. And we'll call that configuration. And we're also going to read in a mapper object, as usual. So let's bring in those namespaces using AutoMapper and make sure you use Microsoft extensions configuration. And then we'll assign those to private read-only fields, so underscore config equals configuration and underscore mapper. Oh, goodness. Equals mapper. Then we'll just generate those read-only fields. Fantastic. Okay. And so really all we need to do is come on and flesh out this method here. But before we do that, I think it's probably worth doing the automapper stuff now. So let's just come back over to our profiles folder. And we're going to put a new profile in here. Right, so under here, we're going to create another map. And we're going to define the source. Now, what is the source in this case? The source in this case is a gRPC platform model. Now, you'll remember if we come back over to our Protos file, in here, this is basically the source, because we're going to be getting these, albeit an enumeration, we're going to be getting these from our endpoint. And so we need to map it to our platform model as we specified here, platform. So let me just bring in the namespace for that using platform service. And we need to do some mappings. So let's just come back again to here. We're going to be bringing over our platform ID, our name and our publisher. So I'm probably not going to bother with the publisher because from memory, I don't think we're even storing that in this service, so it's irrelevant. The name will map over, but that should map automatically. But this here, the platform ID, we want to map it to the external ID of our platform model. So we need to set up some mappings. So don't forget the parenthesis, and we'll come on to a new line, and we'll have to do this for member type stuff. So same thing as we've done before, specifying the destination. So the destination is on our platform object, so here, external ID. So it's actually very similar to what we've already done up here. And put the comma in the right place. So OPT goes to OPT. Oh. And what are we mapping from? We're mapping from our source. And oh, I've got that completely wrong, so let's put that around the right way. What we're mapping from, we're mapping from our source. And it's platform ID. Now again, like with the other mappings we did in the platform service, we probably don't need to do this next mapping, but I'm going to do it anyway. So for member, we'll copy this and we'll just change the values. I'm going to map over the name value, but that should auto map. So we're saying the name destination on our platform model, we're going to map to the name from our source. The only reason I'm doing this, I'm double checking it, is because we're using gRPC and I just want to be doubly confident that we're mapping everything through that we want to map through. Now the other thing I want to do is I want to do an ignore. So for our destination method, dest commands, I just want to ignore that. And I think it would be ignored anyway, but again, I just want to be explicit in the fact that we are ignoring any mapping of command objects or a command collection. So I'm just going to go ignore. So we don't, automapper doesn't even attempt to do anything from that. So I think, to be honest with you, this is the only thing we really need to do by way of mapping. This other stuff is probably not necessary, but I'm doing it just to be doubly sure. So we'll save that off. That's our automapper stuff done. And I think that is all our automapper stuff for the whole project now finished. We're really coming to the end of things now. So back over to our platform data client, we've got our mappings in place now, so we can now finish off this method here. So let's get rid of this. And I'm just going to do a console, bring in the namespace using system write line. And we're just going to say calling gRPC service. And what we might do, we'll actually name the service just so we can kind of see what it is we think we're calling. So curly brackets, and we'll use configuration. And then we'll bring back the config item. So let me just go and pull that out. Oh, keep doing Control V instead of Control B. So let's come back to one of our config files. This is the value we want here. So let's copy that into here. All right. And we'll just end that like that. So I think that should be okay. Cool. Again, just helps us with debugging a little bit. So we now have to set a few things up in order to talk to our endpoint. So the first thing we need to set up is a channel. And again, this is a different channel concept to the one from RabbitMQ. So we'll declare a gRPC channel. Bring in the namespace for that. Using gRPC net client for address. And then we specify our endpoint, and it's actually exactly the same as this. We're just pulling in the endpoint. So I'll paste that in there, that's so. And I don't think we need that. There we go, that looks better. There we go. Fantastic, and then we need to declare a client. And that's equal to new gRPC platform. Bring in the namespace for that. Platform service. So again, all this stuff will only work if you've built the solution and it's built the code behind for the proto file. So gRPC platform and gRPC platform client, and then we pass in the channel like that. And then we want to declare our request, which is basically an empty object really. So that's equal to new get all request, which again is basically, we come back over here, is just this thing here. Okay, so it's not nothing, but it's, yeah, sort of nothing almost. All right, so then we're ready to actually make our call to get all platforms. So we'll put that in a try catch block. I'll move this up a bit, and we'll do the catch first. So that's usually easier to declare. So same as usual, exception EX. We'll do a console write line. I'll make it $sign at front. We'll say could not call gRPC server, and we'll put the exception in here. Right, and semicolon. Then finally within our try block we want to get a reply equal to client get all platforms. And we pass in the kind of dummy request. And I'll just fix that up. Reply. Okay. And then finally we want to return mapper map. What do we want to map to? Now enumerable of platforms. And what is the source? The source is a reply dot platform. And that should be the client done. And we actually should probably put, it was complaining we're not returning something for everything, so we'll just return a null in here. And that should resolve the errors there. That's it. So the client's relatively simple. We're just putting in our configuration object, a mapper object, set up a channel, set up a client, dummy request, and then we just make the request as so. So it's not that complicated. All right, so that's it, almost at a point where we're done. All that remains to be done is calling this at startup. So what we're going to do is we're going to create a prepDB class, a static prepDB class like we did with our platform service. We don't have one here yet. We'll quickly knock that up just to keep it consistent, and then we'll call this service from within there, and we'll seed in the platform data that we get from this method, and that's us, we're done. Well, and then we have to deploy to production, but if this all works locally, then I'm fairly confident, given what we've done so far, it should work okay in production. So we'll come on to doing the last real bit of coding, which is the prepDB class, to retrieve this information from our server. All right, so still within our command service. In fact, before we come on to doing the prepDB stuff, let's just do a .NET build, just to make sure we are all still working okay. Great, and actually, before we even come on to doing prepDB, the one thing I did forget, and I keep forgetting, we need to register for dependency injection our interface and our concrete class because we're going to inject or get a reference to those anyway within our prep.db class. So let's just do that now. So let's close all this down. Let's come into our startup class. Let me get rid of my terminal. And let's come into configure services. And we'll just put that after this. So services, we're going to add a scoped lifetime. And we're going to pull in, or we're going to say that an I platform data service will give us a platform data service. Let's just pull in the namespace. I think I've probably, yeah, platform data service. That looks okay. Must be something wrong. Platform data client, not service. Been a long video, getting confused at the end of it. So yes, it's our client, isn't it? Of course. So let's try that again. And yeah, there we are. These both should resolve now. Great. So let's just do a .NET build again. Let's do a .NET run, in fact, just to make sure we're all looking okay. Yeah, that's all looking fine. Fantastic. So yes, now last class of the whole project is our prep.db class that was going to call our gRPC client code. So let's just close that down. Let's minimize that. And then in our data folder, right click, new file, prepdb.cs. All right, so namespace, command service, data, and it's a public static class called prepdb. Fantastic. Then we're going to create a private public method, not a private public method. That makes absolutely no sense. A public void public static method, public static void, and we're going to call it prep population. And we're going to inject an iApplication builder into that. Called application builder. We'll pull in that namespace. And we'll use that ultimately to get a service scope again, because again, we can't use constructor dependency injection because it is a static class. So we'll create a service scope. And we'll go to application builder, application services, create scope. And we'll need to bring in the namespace for create scope. There we go. So we want to get our client, our gRPC client. So gRPC client equals service scope, service provider, get service. And what do we want to get? We want to get an I platform data client. And that's what we just created from the last section. So let's bring in the namespace. Fantastic. And then we want to basically get a collection of platforms. So we'll create a platforms collection and make that equal to gRPC client. And then we will call return all platforms. And then, like our other prepdb class in our platform service, we're going to create a private static void method called seedData. Into that, we're going to expect an I command repo. We'll call that repo. And we're going to expect an I enumerable of platform objects, which is basically a result set from the method, the prep population method. We'll call that platforms. All right, so I just want to make sure that we have that namespace. So systems collection is generic, and then bring in our platform. Actually, you want to do that using a using statement. There we go. And so then we're going to call this method from in here before we finish seedData. We're going to call seedData use our service scope again, service provider, get service, and we're going to get an iCommander repo, and then we're going to pass in our platforms from here. Okay, and I forgot to put the parenthesis on the end there. Okay, that should resolve. Fantastic. So again, yeah, into our seed data method, we're passing a repository. We're just getting that from our service scope again, and we'll pass through our platforms, which we retrieved from here. And then finally, we want to push the data into our database. So console write line, bring in the namespace, and we'll just say seeding new platforms. Fingers are getting tired after all the typing, so almost there, the last for each loop. So we're going to say for each platform in our collection, we're going to do a check. So we're going to say if not underscore repo, not underscore, so used to saying underscore repo, external platform exists, plat, external ID. So if we don't have it, then we will add the platform to our database. So we'll say console write line. Actually, we won't bother with a console write line in here. We'll just use repo, create platform, and pass in the platform object. So this just means we're not duplicating platforms or ones that we already have, using the platform service ID as the kind of global key. And then irrespective, we'll just save changes. So we may or may not add anything, doesn't matter. We'll just call save changes. Fantastic. All right, so yeah, all then that remains to be done is we just need to come over to our startup class, and we need to call our prepdb, or call our prep population method off our prepdb class. So prepdb, prep population, and we just need to pass through our app instance as so. So that is it. That is it, assuming we haven't made any errors. So .NET build to build it up. Looks good. So good quick pause here. We've done quite a bit of coding here. So in the next section, we're going to run both of these up locally, and we're going to test to see if our gRPC stuff actually works. And then we'll take it from there. All right, so on to testing our gRPC stuff. So let us come back over to our platform service. Here we are. And clear the screen, we'll do a .NET run. So we're using a memory database, everything's looking pretty good. So we're not really going to do anything with this now. Let's just check to see, it should have data in its repository, in its database. So into our platform service, we'll do get all platforms, send, and we have all our platforms there, the 3 platforms. Now, what we want to do is run up our commands service, and it should start up. It should use gRPC to pull those same commands into its repository. And if that does work, then we know it has worked correctly. So let's do a .NET run. So looks pretty good. So it's listening on the event bus, which we want it to do. It's calling the gRPC service at HTTPS port 5001, and it looks like it's seeding that data into its database. So if we come over here to our command service and we get all platforms, we get the 3 platforms that we had in our platform service. So using gRPC to get that data, which is very, very good news. And then just to kind of labor the point, if we come back to our platform service and we create a new platform, and then we come back to our command service and get all platforms, we have that platform as well delivered via our event bus So the two services are now completely in sync, and we're using synchronous messaging and asynchronous messaging to achieve that. And really, although this was a very simple example, you saw how much work went into creating it, but fundamentally those techniques that we have used here are then usable in much, much more complex setups. So it's a good foundation on which to move forward. So very pleased with that, glad that all worked. All we have to do now, and it could be a little bit of a sticking point, is we need to repackage or rebuild both our images, push them up to Docker Hub, and then restart our deployment in Kubernetes. Now, we did have that unique config stuff that we put in because we're not using HTTPS within Kubernetes, so that might cause a sticking point. Shouldn't do, should work okay, but that's our last thing that we need to do. So let's just finish this off and get that done, do a quick test, and then we can all go home. So we'll do that next. All right, the moment of truth. Let's just stop all our local running services just to give us a clean slate. And let's start with our platform service. So yes, what we want to do is we want to rebuild the image. So do a directory listing, make sure you're in the platform service folder, make sure you can see your Docker file. Then we'll do Docker build. Platform service, don't forget the build context. So let's just do that. Oh yeah, I forgot to tag it. After all this time, there you go. I think it's the first time I've made that mistake. We didn't tag it. So Docker build -t and then the name of the service. Don't want to make any stupid mistakes at this point in the game. All right, it should build relatively quickly, but because we've added some newer code in, it might take a bit longer to build. It builds, again, builds the images in layers, and we've added quite a bit of code, so it's probably updating a few more layers than it would have done if we'd made only some minor changes. So it's probably pulling in all the gRPC stuff, actually. That's probably why it's taking a bit longer. So let's just let that do its thing. All right, that's built. So up key, and we'll just push this up to Docker Hub. Push. All right, we'll just let that push up. And in the meantime, let's come over, I just want to wait, yeah. In the meantime, let's come over to our command service, and we'll do a directory listing. Make sure you're in the commands service, and we'll do a Docker build. Don't forget the T this time, binary thistle, and it's command service, and don't forget the build context. So let's just check that's correct. Binary thistle command service, fantastic. Let's rebuild that. Fantastic, an up key, and we'll just push up to Docker Hub. And then as usual, once both of these things have pushed, we will check Docker Hub to make sure that both our images were actually pushed up and we hadn't made any mistakes, and that we have the latest images up there. So I might just wait for that to happen, and we'll come back and double check Docker Hub. All right, so that's our platform service pushed up. Let's see how our command service is doing. It's still running along, so we'll just wait for that to finish as well. All right, so that's our command service finished. Our platform service should have finished as well. Indeed it has, fantastic. So let's just come over to Docker Hub. We'll do a quick refresh, and hopefully we should see a few seconds ago, a minute ago. That makes sense to me, fine. So they look like they have been pushed up successfully, and we haven't got any other images, misspelled images or anything. That's good. So last thing, we're going to do a kubectl rollout restart, and then we will make a, well, we'll see actually almost immediately when the command service starts up whether the gRPC stuff was successful. So we'll do that next. All right, so let's come back to our platform service. I think we're already there. Yeah, we're already there. Let's clear the screen. So yeah, we want to just get our deployment. So kubectl get deployment. And we basically just want to restart our platform's deployment. So kubectl rollout restart deployment, and we want to restart this deployment here. So that's restarted, so we'll do kubectl get pods. And we'll see that the container is creating. I've opened a beer at this stage, so I'm fairly confident it's going to work. Let's do another get pods, still creating. Again, and you can see that the old pod is terminating, so that shouldn't take too long to terminate. So let's bring Kubernetes back over. We'll order by start time. So our platform service should be the first one that started. I just want to make sure that everything's looking sort of okay. Yep, it's looking all right. There's nothing too concerning there. And actually, one thing we can see is that it's listening on port 666 as well, which is good news. So we're on port 80 for our HTTP traffic, and it is listening on 666 for gRPC, so that's looking pretty good. Now, maybe before we do anything else with our other service, I just want to make sure that we can still call our endpoint. So let's just say, not in our command service, in our platform service, get all platforms. Yeah, we have all our platforms there. It's all still working fine. Fantastic. So, moment of truth, real moment of truth. Let's clear the screen, get our deployments again, and we want to restart our commands deployment. So .key up key, rollout restart, and this time it's commands, and we'll restart that. And we'll do get pods, and we should see container creating, and again, shouldn't take too long, and at this point, when it starts up, should use gRPC to pull down all the platforms that we have running in our platform service. So fingers crossed, we'll see how it goes. Let's just check our pods again. Okay, so our old pod is terminating, it's gone, that's looking good. Let's just do, okay, it's all running up. So that's a really good sign. We're not seeing it erroring out, which is obviously a good sign. So let's sort by start time again, and it's our command service at the top. And we should see here, calling the gRPC service, seeding new platforms. I think that looks good. So let's come back to our production queries and get all platforms from our commands service. Indeed, it did. It pulled down all of our platforms. Fantastic. So with that incredibly long video, we have finished and we've deployed everything to production running in Kubernetes. So if you followed this far, thank you for following this far. It's been a very, very long video. Now, I do have some final thoughts on a bit of a review of what we've done, and just go back through reviewing what we have done, and there are some final thoughts on things that we could do to move this forward even more, the things I left out that I would maybe include the next time. So quick pause, I'll finish my beer, and then we'll come back and we'll talk about those things before wrapping up. All right, so here's just some final thoughts from myself on how I would move forward if I was to revisit this course or add some more material into it. As you're, I'm sure, very aware, it was a very long course, a very long video, but we didn't cover everything. I mean, you're probably never going to cover everything, but there's some things that I would probably introduce if I was going to extend it going forward, and this is just my thoughts at this point in time. So the first thing I would like to look at is HTTPS, TLS, whatever you want to call it. I don't like ignoring that at any point in time, so I would definitely want to at least revisit it in more detail and make a more of a considered assessment of whether we would want to use it within our Kubernetes cluster or not. We didn't, obviously, and that may still be the case, but I'd probably want to focus in on that a little more and at least provide some options for introducing HTTPS into a Kubernetes cluster. I'd probably want to revisit the event processor. It was just one big kind of massive class, so I think that could be a bit more elegant, and I'd probably think about re-architecting that, but for our purposes it was fine. Possibly a more elaborate use case. Our use case was very, very simple, which I think for this video was the right approach. It didn't detract us from what we really needed to focus on. But going forward, I think a more elaborate business-focused use case would be probably beneficial, because you then have to start really thinking about how eventing works. And this kind of feeds into the point above, really. So that might drive a more elegant eventing system. And then the last one, service discovery. So that means that services can discover each other without having to have hard-coded endpoints, which I think is a really nice concept. And it might also address some of the issues that I called out with synchronous messaging. Some of them anyway, not all of them. So something I possibly would look at introducing into another course going forward. I'm sure there's other things, but those were my top 4. Other than that, thank you for watching. If you liked the video, give it a like. If you haven't done so already, please think about subscribing. But until I make my next video, stay safe, and I'll see you next time.